Good morning, everyone. What I'm going to share with you is a presentation about the Angra 1 simulator, update and training, that due to the events of 2020, the title became into remote update and training. I have divided this presentation into 5 parts. I will start with a brief presentation about us and who we are. Then I'll move on to the description of the project scope, and I will explain how was the initial schedule. Next, we'll see how the project was affected by the COVID pandemic during last year and how we solved the situation thanks to the remote working. And finally, I will spend some minutes talking about the conclusions. So, as I said, who we are. For those who don't know about us, Tecnatom is an engineering company that has been providing services since 1957. We are an international group headquartered in Spain with subsidiaries in different countries such as Brazil, Argentina, Mexico, United States, and China. And as you can see in this slide, we develop projects all around the world. The mission of Tecnatom is to ensure the safe, efficient, and excellent operation of its power and industrial plants. Let me say that our driver is always the customer satisfaction, and our best value are people who really make the difference. I'd also like to highlight our value of innovation and technology, our levers to add value, and our capacity to address new challenges. Our primary activities are inspection and structural integrity services, operation personnel training via the use of full scope simulators, and plant operation support engineering. In this presentation, I'm going to be focused on a project that belongs to the area of simulation, but as you can see in the slide, Tecnatom has a large variety of services and operates in different markets. I think I have said enough about the company, so now let's move on to the project. The project I'm going to present was developed for the simulator of the nuclear power plant Angra 1 in Brazil. The full scope simulator was developed in 2015 by Tecnatom, and the simulator was using a simulation solution of the turbine and feedwater control system existing in the plant at that date. That was based in the WDPF automation. But since then, it has been upgraded, this turbine control system at the nuclear power plant, to use an Ovation 3.2 based system. So the simulator needed to be updated to reflect the new Ovation system and match the plant. And Tecnatom was commissioned with that work, and the modifications were planned to be realized during last year, starting in January and ending by November. We were 3 companies involved in this project. So Tecnatom as the service supplier, Westinghouse, that was the hardware supplier, and Electronuclear, so ETN, that was the client. Let's see how was the initial schedule of the project. Well, the project had been planified taking into account the usual phases for a project of this type. So it was a first development phase where the activities planified are described in this slide. The preparation of a test bed for the development, integration, and testing activities of the project. The analysis of both Ovation system and plant models in order to identify the input-output variables that needed to be communicated, and implementation of the modifications of the simulation models as the new solution tool was going to be incorporated in the simulation server, replacing the existing simulated code, and so interfacing with the plant models. Therefore, the existing turbine control and feedwater code must be isolated and removed from the simulator, and the simulation models needed to be adapted in order to communicate with the new Ovation. And that was the last activity of this first phase. Once development was finished, the next step was the integration of the Ovation platform with the simulated components, and then we would be ready to begin the factory tests with the aim of validate the new turbine control and feed water system behavior using the new Ovation-based control logic. And once the tests were successfully executed, Technaton would prepare the packaging of the equipment to send them to Angra. With all the material received in Angra, the Ovation platform had to be installed in the simulator, and Technaton could begin the modifications on site. This installation included 4 slims, 4 drops or workstations, servers and switches in order to link Ovation platform and simulation components, and of course, to realize all the cabling to connect all the components. And then ETN with Technaton and Westinghouse would execute the site tests following the set procedures previously validated. And the last activity was the training that had been planned to train personnel in order to use the HMI applications and how to update the system for a new plant release. As we were 3 companies and 3 countries involved in this project, let's see now where the activities have been planned and the estimated dates. The development was going to be done in Spain and had to be finished by March. The integration and factory tests were going to be executed in United States and were planned to be finished by July 2020. And the rest of activities, so the installation, site tests, and training, were going to be executed in Brazil, and other projects had to be finished in November. Well, so until now, I have explained how was the project planified, and now let's see the reality and how these activities were finally carried out. Well, the project started with a classical kickoff meeting in January, and Technaton started the development phase, which was finished in March 2020. Then, when all the travels were arranged to United States, the COVID came into our lives with the new rules forbidding suddenly to travel and social contacts. And so, all the rest of activities had to be reorganized in order to accomplish all the new requirements, but always keeping focus on the aim of the project and our commitment to the client. From now on, we are going to see each of these activities and compare what was planned versus what really happened. Let me tell you that it had a happy ending, but with not few COVID adaptations. Well, the first activity post-COVID planned was the integration of the Ovation platform with the simulated components. For that, the platform that had been developed in Spain in the previous phase had to be sent to USA, where Westinghouse and Technaton were going to work together and in person for the integration. Well, the platform was shipped as planned, and I have to say that it arrived faster than ever. We think it may have been the only passenger at that time, as it was April. However, the integration, instead of being done in person, it had to be done remotely. Our team was connected during the whole American day in order to successfully realize integration. And I like to say here that by then they were still accomplished. For the factory tests, it was very similar, as the tests had to be executed in the United States with the recently integrated platform. This time, the participants involved in the tests were Westinghouse, Technaton, and ETN. These tests were executed successfully, but again in remote. And remember, the platform was in USA, as well as the Westinghouse team. The Technaton team was in the office in Spain, and ETN was in Brazil. For the execution of these tests, we had to design a strategy in order to visualize all the components involved in the test and in order to ensure everything was working correctly. So the server simulation was all the time in the shared screen, and there was a webcam pointing at the four slims. And all of this information was shared by all the participants all the time. Here you have some picture of these long days. As you can see, all of them wearing masks or respecting social contact. And you can see it, but I can assure you that there was a lot of ventilation. We find the right and above all the safe moment to travel in November, when the following three things happened at the same time. So the platform that came from USA had arrived to Angra. That was very critical as it was the platform to install. Second thing was that Brazil at last had opened the travel restriction to foreigners. And the last push was that in Spain, the autumn was starting, and we hit the third wave of COVID. So grab of Spain was not a bad idea at all. And then, with installation finished, the rest of Technatom team arrived to Angra to execute the site tests. For this activity, there were two differences from what was planned. The first one, that Westinghouse was going to give support remotely. And the second one that had already been put in place for the previous activity was the safety protocol that all of them had to follow and that all of us know very well. So that was the use of masks, the respect of the social distance, the use of hydroalcohol, and all the PCR tests we have to do. At that point, I have to say that our client, ETN, strictly complied with all the sanitary rules I made and made us feel safe at all moments. At the end of the test, it was already December, and there was only one activity to do. That was the training, and that it had already been decided that it would be realized in remote, and in January. So, in fact, there were only two things that worried us. The first one was to obtain the ready for training of the simulator, and the second one, be negative in the PCR tests and enjoy Christmas with the family at home. And as I told you at the beginning, this project had a happy ending. So that means we obtained the ready for training and all the members of the team went back home safe and sound. And finally, we arrive to the conclusions. First, I'd like you to see these two pictures, as I think they are very representative of what happened. The one on the left is a picture taken in the kickoff meeting, and the other one is a picture of the last days of the site tests. Only 9 months separate these two pictures. However, it seemed the first picture was taken in another life, doesn't it? I'd like to say that projects that were launched before the global health pandemic, but they were fully affected, had to demonstrate a huge adaptation to change, as even if we know that reality always beats planning, this time it was really unthinkable. However, I think we have been surprised by our own reaction facing this situation, and we have a lot of examples of successful projects under these new and sudden conditions. In our case, I'd like to highlight once again the adaptation to change and our capacity of keeping focused on the client. I told you at the beginning that it was one of our values, and I really think we have demonstrated. We also really think that the success of the project is due to the teamwork between the three companies that really built a very good work environment that we all know that boosts productivity. And finally, I'd like to say that behind this project, there has been a hard management work, as there have been so many new variables to take into account in order to ensure the delivery of the final product. Some examples of this project management are the need of increasing the frequency of risk management. Scheduled travels was harder as there were sanitary requirements changing almost every week. We had to increase the communication with the client to always be aligned with them. And of course, if always we take care about the team, at this situation, it was more necessary than ever. As if you remember, at the beginning of the pandemic, it was a scenario of total uncertainty. And that brings me to the end of the presentation. So I just want to say thank you for your attention.
Experiences and a lot of new impulses from the high quality experts. Today I came with my colleague and we will share with you some new approaches, how to use our OTS systems beyond the regular way. Okay, if you take a look to the agenda, you can see the rhythm of our presentation. We want to begin with the current system introduction and later to go through on the new possibilities till the future plans. Okay, first and foremost, let me introduce myself. My name is Tibor Szabó. I'm a downstream specialist. I came from Hungary, from Százhalombatta refinery. I'm a member of Process Automation Information team since 2008, and I work for MOL PLC since 1994. It's a very long time. I led a small stream within the big team named Advanced Safety and Reliability Application. Beside the OTS, we are working with alarm management, for instance, control room monitoring, HP, HMI, cybersecurity, whatsoever. Beside that, we manage projects and very actively take part in the upset investigation too. So a few things, few personal things about myself. As you can see, I have a lot of hobbies. One of the most decisive is the football. As you can see, I like the money because one of my hobbies is the numismatics. My most active sport activity is related with my youngest family member, who has to need a lot of time to spend together. This is the reason to go to school again, actually to a dog school permanently. So finally, if I have to mention my biggest experience ever, I want to highlight the most expressive thing which happened to me when I went by a small boat under the Niagara Falls. So, okay, let's pass the word to my colleague, Pál, to introduce himself also.
My name is Pál Farkas. I got my first job in 1987. 16 years ago, I started to work in the oil industry. Initially, I worked as a field operator. Next, I became a control room board operator. After that, I was promoted to the position of operator training simulator trainer. During this time, I realized that I want to study for an academic degree. Now, I have successfully completed 2 courses. During the last 4 years, I've been a member of the Process Information and Automation team at the Danube refinery in Hungary. I work as a process information expert. Throughout these 1.5 decades, I've been an employee of MOL. Let's move on to introduce the MOL company. Since its privatization in the 90s, MOL has successfully grown and transformed into an international oil and gas company with market-leading position in many Central and Eastern European economies. A progressive vision, a well-executed regional strategy, and strong leadership. These were the necessary ingredients to shape MOL into it is now. Today, MOL has an integrated business model that can deliver stable and robust profitability. This gives us the right platform and the necessary resources to tackle new challenges that arise. The world around us is changing fast, driven by rapid technological development, shifting consumer preferences, and an evolving regulatory landscape. The oil and gas industry will have to change fundamentally as well. We want to lead these changes, we want to be a solution, and we see a clear opportunity to make ourselves better. Today, our integrated upstream-downstream business model remains the basis of our operation. This business model has provided by stability in the fluctuating external environment. However, our external environment is changing more rapidly than it has ever before, carrying the risk of decreasing demand for fossil fuel in the long term, while at the same time customer habits and needs are also rapidly changing. We have the capability and the professional know-how to take opportunities provided by the changing environment. Let's talk about the downstream department. It has 3 refineries and 2 petrochemical plants, transforms crude oil into a range of refined products for domestic, industrial, and transport use. The products include, among others, gas oil, diesel, heating oil, aviation fuel, lubricants, bitumen, sulfur, and liquefied petroleum gas, for example. We already have a plan enhancing flexibility in refining by reducing the motor fuel yield from 70% to 50% by 2030, mostly through increasing feedstock transfer to chemicals, especially polymer raw material. We have deeply integrated portfolio of downstream assets, complex and flexible core refineries, very strong market presence. Our retail network is fully within the refinery supply radius. We have enhanced access to alternative crude supply. According to new research by McKinsey, the pandemic has resulted in a profound reduction in energy demand, and it will take between 1 to 4 years to recover. However, the report states that demand for fossil fuels will never return to its pre-pandemic growth curve. Just because this trigger exists, we have the 7 major steps planned to step into the new low-carbon world. Most of them are already or have started to go live recently. Thank you for the attention. Let me hand you over to Tibor, who will now continue.
Okay. Thank you, Pal. So let me talk a very few words about our current existing OTS portfolio. So as you can see, we initiated the very first project in 2007, and we have implemented 10 high-fidelity custom OTS systems so far, 9 of them made by Honeywell, and the youngest one has completed by Emerson. Always the legitimate question, how can we use the OTS system? What is the goal in the refinery of the system utilization? Well, the utilization of the system is unbroken, and the popularity is unquestionable nowadays. So we separated 4 categories for the topics. The first category is the what if, means all of the exercises which base in an unfamiliar technology event which should potentially be happened. So we can improve special skills, self-confidence, and more effective interventions for the operators. The second option is the opposite topic of the first one, and emphasize the trainings for events which have already happened to find the best practice to treat and handle the upset. With the third topic, we can maintain the knowledge for the sequential activities. For example, unit startup, heater startup, compressor startup, whatsoever. Last but not least, the optimization, which allow the operators to dig down into the technology and provide capability for the fine-tuning and interventions to be better quality of products. Okay, let me show you a new Power BI report as well, what we also created for monitoring the performance of the trainer and the system in order to public the system utilization. Okay, right now, let's look what is the reason and what is the applications, what we can show for the participants, I mean the trainees on the operator training simulator, which is so far from the regular system utilization. One of the most impressive intention in the refinery to provide quality of alarm for the panel operators. For this reason, we have initiated an alarm management program a couple of years ago to collect the bad signals, to analyze the root causes, and to provide the best for the operation. To tell the truth, this is like all of new things, also a very challenging task. We learned a lot, trained ourselves many times to know what we want, and discussed, presented a lot to make understand the goals. After a while, initiated a special program to use the OTS for making acceptance about the alarm management meaning and essential. Let's look how is it work. The OTS is very useful to show the operator the influence of the different alarm limits, how the response time, the proper intervention, and the abnormal situation will be done with deficit if the badly chosen alarm limit has set up. How the alarm priority investigation can help the operator to take proper intervention if something goes wrong on the technology. How many alarm types can be chosen if needed to get as good and precise alarm parameter as available. Last but not least, what kind of advanced alarm techniques can be implemented? I mean, delay time, shelving, whatsoever, if we want to improve and develop the alarm system. All in all, we want to provide as wide information as we can and use the OTS possibilities for training to gain benefit about the response time decreasing, the proper intervention improvement, and the higher responsibility for the alarm handling. If we want to make understand the alarm management with all of segments, we need to deal with the custom display and the HMI philosophy as well. This topic is also very important for deepen knowledge and last but not least increase acceptance of new solutions. For example, to know the main points of HMI philosophy, the standards, important to know what is the difference between the old and the new pictures. I mean the colorful picture and the very plastic, I mean the gray and the very pale colors. How the four-level hierarchy can be used and understood for more effective technology management. For this reason, we provide new example custom displays for training. Many discussions, many examples, many arguments. Unfortunately, this is the hardest topic ever to change the mind and break with the traditional habits. This is the reason why we want to looking for a real breakthrough on the OTS trainings to deal with this issue. The last topic, what we train, how the control room problem can be recognized for the panel operator. What kind of issue can be assumed if the error detected? Why so important to recognize in time the oscillation and the sticking of the valve? How the effectiveness can be improved if the operator has got enough experience and knowledge about these topics? So, to tell the truth, we strive to prepare some training material on the OTS generally to make understand as much as we can. So, thank you very much for your kind attention so far. Let me pass the word to my colleague again, who will tell another extreme form of system utilization.
Thank you, Tibor. Now, I'd like to share with you two examples of cases where OTS can provide excellent opportunity to resolve issues that we have not yet taken place in real life, or where the OTS could support decisions in such situations. In both cases, I will mention the Danube refinery plants in Százhalombatta in Hungary. In the first example, I'm talking about a hydrogen production unit, where the hot flue gas flowing through when the gas gives its valuable thermal energy to the water, which water goes further to a steam generator. After the preheater, the partially cooled flue gas is going through to the flue gas fan. This fan has a maximum flue gas temperature limit. If the flowing water in the preheater does not remove the heat from the flue gas, there is a chance that it will be too hot for the flue gas fan. In this case, we may reach the maximum temperature limit and causing a shutdown of the hydrogen production unit completely. And at once, this preheater went out of order suddenly because it has become leaked. The question we were looking for, how we could operate by shutting off the water from the preheater without the flue gas remain too hot to the flue gas fan. So a relatively quick decision was needed because several of our hydrogen consuming units depends on hydrogen producing plant, example hydrogen desulfurization technologies. An emergency shutdown or a sudden lack of hydrogen would have caused several units to shut down also. All in all, causing hundreds of thousands of dollars in economic losses through lack of production. The solution was provided by the existing OTS at this plant. While the plant began to slow production, this was also done on OTS in parallel, ahead of the while until the sorry guys, megállt a just something happened with the animation. I have to repeat the whole part of this. Yes, let's try again. I'm sorry. Thank you, Tibor. Now I'd like to share with you two examples of cases where OTS can provide excellent opportunity to resolve issues that we have not yet taken place in real life, or where the OTS could support decisions in such situations. In both cases, I will mention the Danube refinery plants in Szászhalombatta in Hungary. In the first example, I am talking about hydrogen production unit, where the hot flue gas flowing through when the gas gives its valuable thermal energy to the water, which water goes further to a steam generator. After the preheater, the partially cooled flue gas is going through to the flue gas fan. This fan has a maximum flue gas temperature limit. If the flowing water in the preheater does not remove the heat from the flue gas, there is a chance that it will be too hot for the flue gas fan. In this case, we may reach the maximum temperature limit and causing a shutdown of the hydrogen production unit completely. And at once, this preheater went out of order suddenly because it has become leaked. The question we were looking for, that how we could operate by shutting off the water from the preheater without the flue gas remain too hot to the flue gas fan. So a relative quick decision was needed because several of our hydrogen consuming units depend on this hydrogen production plant, example hydrogen desulfurization technologies. An emergency shutdown or sudden lack of hydrogen would have caused several units to shut down also. All in all, causing hundreds of thousands of dollars in economic losses through lack of production. The solution was provided by the existing HQ OTS at this plant. While the plant began to slow production, this was also done on OTS in parallel, ahead of the live unit with a little time. The OTS trainer communicated with the operating staff via hand radio. We reduced the feed of the unit. He shut the water from the preheater on the OTS simulation and monitored the temperature maximums. As the OTS trainer found that this flue gas temperature did not reach the strict maximum limits for the flue gas fan, he told this result to the operating staff, whom then also cut the water flow in the real life, in the real unit. Thus, significant material losses due to unplanned downtime could be avoided, which did not happen, thanks for the support of simulation. In my second example, I have to refer to a recent worldwide event. The pandemic can affect us in many ways. As a result, we also had to face several different challenges at the Danube refinery. Although the Danube refinery is still able to serve a wide range of market changes due to its high degree of complexity and flexibility. But when the demand for our products has dropped dramatically and very quickly, the temporary shutdown of several of our units have become a realistic option. In the oil refinery chain, one unit depends on another in terms of product feedstock. If the operational difficulties experienced at one plant have an almost immediate impact on the other units. Within extraordinary operating conditions, for example, operation below the previous minimum feed flow level, or the partial backmixing an intermediate product of a unit into its own raw material have also been raised. Although OTS vendors guarantee high accuracy of OTS within normal operation, the model can run outside of these guaranteed limits and still be able to provide us some results in this special operation also. In this particular example, I am talking about a fluid catalytic cracking unit where we had exactly the same required unit operation. In general, to run a complex unit like FCC unit, with minimum feedstock for a limited time is better choice than to stop and go later if any or limited feedstock is available. This is an economic related decision. The minimum feed consumption of a unit is a specification, and we hadn't any experiences to run FCC unit below the minimum feed. Just because of the low demand for the product, we have decided to run FCC below the previously happened feed volume. This and similar demand of simulation answers great opportunities to use HQOTS simulation sessions to have the answer for the unknown. If requires fine-tuning of all OTS systems to be able to use for such operational experiments, then this fine-tuning have to perform. We see a great opportunity to make our existing OTSs suitable to do it. And in the future, if we build again a new OTS system, we will take this at the design stage in order to be able to model such and similar operation conditions. From the process information and automation side, we want to further increase the utilization of our OTSs, especially for unusual operational experiments that we were not previously part of the daily practice or seemed unthinkable before.
Slowly approaching the finalization of the presentation. And I suppose we could share few interesting information. But before we finish, I would like to finally let me talk a few words about the future. We know that we should be able to save a lot of money if we can virtualize the system. It is a core topic in the near future. If we will virtualize the system, why not we provide, for instance, a remote availability of the systems from home office training, for instance. Another sharp issue what we are able to support with OTS in the next time, the process engineering daily work, the corrosion monitoring, for instance, like a new topic beside the mentioned other trees, the technological parameter revision or set up new parameters, or like nowadays we were dealing with the incident investigation, like expert as also a very good way should be to expand the possibility for utilization of the operator training simulator. So actually we have a lot of new ideas and recommendations, but we are fully clear about the current situation, and the majority of the implementation can be realistic after the COVID pandemic situation, I think. So, ladies and gentlemen, thank you very much for your kind attention, and we wish you COVID-free future, and we wish you a good day and very good year. Thank you very much.
At Emerson, we are proud to serve essential industries that meet critical global demands and make modern life possible. The needs of these key industries, like life sciences, power, energy, and food and beverage, are transforming and growing as our customers encounter more complex challenges amidst the shifting global and economic landscape. We are helping our customers rise to this challenge every day, providing advanced technologies and expertise built over decades of leading domain knowledge. With our $2.2 billion software portfolio, we are empowering customers to use automation to optimize their operations and realize the benefits of pursuing practical, scalable digital transformation. We enable our customers to use technologies that create safer, more sustainable operations, enhancing reliability and top quartile performance while creating tech-focused, secure jobs for the workforce of the future. Emerson offers a broad range of devices and sensors to allow companies unprecedented insight into their vital equipment. Whether in a pharmaceutical company or offshore oil platform, enable precise management of complex machinery. And we are continuing to build on our strong software and data management technologies to give customers real-time data and operational analytics to identify areas for improvement and to find problems before they occur. We have seen firsthand the impacts of automation in daily life and in moments of challenge that are accelerating the need for digital transformation. We have been working closely with more than 20 pharmaceutical companies to automate operations so they can more quickly manufacture life-saving vaccines and treatments. We have quickly pivoted to meet changing manufacturing capacity needs amidst the COVID-19 pandemic, and we are positioned to help our customers continue exploring automation as a value driver for decades to come. Everything we do at Emerson supports essential industries and drives innovation that makes the world healthier, safer, smarter, and more sustainable.
Welcome everybody to my presentation about training needs from a new energy system. This is my first virtual conference, and I hope that this will work out for all of us. Thanks to Energy Events for that opportunity to present here on the Global Energy Simulation E-Summit. Very excited about that. So let's dive right into the presentation. First of all, as this is a virtual conference and I wanted to give you at least a little view of who you are talking to. So this is me, Peter Lasch. I'm the department manager for simulator engineering at the Simulator Center of KSG. You find my contact data here, so if you don't have the chance to meet up with me in the event, you can use this contact data to reach me. You also find me on Xing and LinkedIn, and I'm always happy to get invites there and to broaden my network, so please don't hesitate to send me an invite. The picture is a pre-corona picture due to the closed barbers. Currently my hair is a bit longer, but I think you will realize me anyhow. Okay, so before I dive into the topic, I'm going to talk about some slides about the company that my CEO always forces me to show. For all of you who don't know the Simulator Center, our main purpose is to do simulator training for the German and the Dutch nuclear power plants. This is what we've been established for back in 1987. We are currently staffed with 100 employees. Out of these 100 employees, we have 40 certified instructors who are conducting the training for our customers. Originally, we had an investment of 260 million here in the company that was mainly for the simulators and the building that we needed to set up to do our purpose. Currently, we have a turnover of 25 million, which is noticeable. And of course, our quality management and our IT operations are certified by the ISO 9001 and the ISO 27001 certificates. And I listed all our shareholders here. These are mainly the German utilities who have nuclear power plants and the Dutch utility, which is operating the Borsele plant. So what do we do here? What training facilities do we have at the simulator center? Of course, we have plant-specific simulators for all our customers. These are currently 6 remaining simulators for 7 nuclear power plants. So 2 plants are sharing 1 simulator. It's full scope simulators with one-to-one replica of the control room where we are conducting our training. So everybody's coming to us and doing the training for their licenses. Next to that, we of course have our renowned, worldwide unique reactor glass model, 1:10 scale model of a pressurized water reactor, where you can see thermohydraulics happening, where you can see what actually is going on inside a reactor. To me, this is always an eye-opener when I see what's going on there with water hammers, condensation flows, reflux condenser modes. This is very, very exciting, not only for reactor operators, but for everybody who's working with steam and water and piping. It's really recommended to see that. And we also do human performance trainings because when you do technical training, you realize soon that you also need to focus on the soft skills training of how people behave. You all know that the biggest source of errors in a technical environment is still the human being. And in order to attack that, we set up some hot water training systems where we let our trainees operate and can then assess their behavior and reflect their practical behavior with the theory that we taught them before. So as you can see, our business is mainly focused on training on assets that are here in our house. People are coming to us, being trained, and well, now you wonder because this presentation is in the remote training section, and what I just told is not very remote training, it's more local training that we are doing. But of course, there are several circumstances that forces us to change the training that we are doing. And in the next few minutes, I want to talk about what these influences are and how they impact us. So the first impact, of course, during these days, I think there's no presentation that gets around this topic. We have the coronavirus, we have the pandemic situation. That is a driver for change because people are not traveling that much anymore, especially if it's not mandatory training that they need to do. We had lots of classes being canceled because people couldn't travel anymore. And that forced us to put many of our trainings, some of our trainings into a remote environment that we also could conduct remote trainings for, especially the soft skills trainings. But this is not the most important driver for us to change. More important to us is, of course, this movement here. For all of us, for all of you who are not Germans and don't know that sticker, it says nuclear power, no thank you. You know that Germany is phasing out of nuclear, and yeah, by coincidence, this presentation is on March 11th. March 11th, also the date of Fukushima. That was the changer here. And yeah, as I said, in the peak time, we had 14 simulators and providing training for all the nuclear power plants. We are down to 6 simulators for 7 nuclear power plants. End of the year, we will lose 2 nuclear power plants. Among them is the new world champion in electricity production. You might have heard that Grunde nuclear power plant has hit the 400 million megawatt hours threshold beginning of February. Well, it would close down end of 21. And this is our main driver for change, why we're going to focus on different training methods. And combined with that is, of course, the new energy transition of Germany. So the question, where is our energy system heading in the future? And the next few slides, I'm going to talk about this study here. It's a study of how Germany can become climate neutral until 2050. That's a two-step process that we are looking for. And due to that study and due to the changing energy system, there will be lots of changes we need to do. And also everybody else that is a training service provider in the energy business will have impacts from this study. And as I said, the next few slides are going to talk about how this study influences our future work and also the future training that needs to be provided. So what is Germany trying to do? We're trying to become climate neutral until 2050, meaning that there are no carbon dioxide emissions anymore. This is a two-step goal. Until 2030, we want to reduce the carbon dioxide emissions to minus 65% compared to the 1990 numbers that we had, where we had an emission of 1,251 million tons of carbon dioxide. Until 2030, we want to reduce that by 65%, and then until 2050 by 95% in total. And if you look at the contributors to this goal, you can see that the energy sector, the energy business, is a big contributor to that. And that is because of the phase out of coal until 2030, the use of renewable energy, and by using hydrogen as a primary source of energy. Next to that, there are the other sectors that contribute to the reduction of carbon dioxide emissions. One to mention is the industry, because the industry currently is also using lots of coal for their energy. And this study thinks that the industry will be completely electrified until 2050, and also using a lot of hydrogen. So you will see by that the landscape that we currently have for the energy production is completely changing in the next decades. And it's a rapid change. The government will lay the footprints for making that change happen in the next 4 years. So if you look at the primary energy consumption, what is remarkable to me is that this study thinks of halving of the primary energy consumptions. So currently in 2018, we are using roughly 13,000 petajoule of primary energy. And back in 2050, this will only be 6,500 petajoule of primary energy consumption left. So how is this done? Of course, we will use energy sources like renewables that don't have so many conversion losses. Currently, thermal power plants just use 40% of the electricity of the primary energy sources that are put in to produce electricity. For renewables, this is almost 100%. And then it also comes in a decrease in the energy consumption that is foreseen, and also in the increase of efficiency. So the heating of buildings, the lighting, all the electric devices will have better energy efficiency, and therefore the use of primary energy consumption can go down. What is also remarkable about this slide is that you see that the primary sources, nuclear energy and coal, will completely vanish until 2030, 35 roughly, and that we are then left with renewables and power to X, so synthetic fuels that are imported to us. For us as a training service provider that is focusing on big utilities like nuclear power plants or conventional power plants, big producing power plants, that gives an impact because these players will be out of the market. If you look at the electricity consumption, you will also see that it changes significantly. There are two sectors to be mentioned that will be contribute to the increased electricity consumption, and that is traffic, because we are planning to electrify the whole traffic sector until 2050. And the other sector is hydrogen production, which is the light blue up here. So mainly due to these three contributors, the hydrogen production, the transportation sector, and the industry sector, the electricity consumption will go up by 360 terawatt hours from now until 2050. And with that, not just the electricity consumption, but also the electricity production will change slightly. This is a duplicate to the slide I had before. But you again see that the electricity production will be changed to renewable energies, and then to back up gas-fired plants that will burn hydrogen, and to import of electricity. So beginning from 2025, Germany will become a net importer of electricity, and this gets even worse if you look at the sources of hydrogen that we are using, because also there 80% of the hydrogen that we're gonna use will be imported. By taking these numbers out of the study, I know they don't quite add up for electricity consumption and electricity production, but these are the numbers of the study. So the question is, why am I talking about that so much as a training service provider? Because, as I said before, the biggest change in this is that we are moving towards renewable energies, and the main point about this energy system is that it will be decentralized. We'll have lots of small production units scattered all over Germany. That is for the solar systems, for the wind turbines, that is for the electrolyzers that produce the hydrogen, and also the industry will electrify all their process steam and their district heating in a decentralized way. So the main question for us and for many service providers, training service providers in the future will be, do you know your customers? Because this is the most important point. There won't be any big utilities anymore. It will be small utilities. And the investments that we had in the past for huge simulators, full scope simulators, that will change. You will have lots of comparable units where you can operate with generic simulations, and also these big training classes that you had in the past where the people are coming to you will change because there are not so many operators anymore, and they are used to operate their plants remotely, because this will also be a trend. So they will also be looking for remote trainings, and that is the most important part that I draw from this study, that the energy system and therefore also the customers for training service providers will change significantly. And we all, as we do training in the energy business, need to adapt for that. And I don't talk about changing aging workforce and replacement of workforce from old engineers to new engineers. That is a whole different story that I won't talk about in this presentation at all. So let's bring in all the buzzwords for remote trainings. What kind of training is needed in the future at all? Where will this be heading? Of course, we will have video conferences where you talk about stuff, where your tutor will be online in a video conference and teach you things. There will be blended learning. Everybody is going into that direction where you mix up classic, I would say, training methods with online training methods. There will be a huge pile of self-paced learning because, as I said, if you have so many standard units that are operating in the grid, you can also put standard training classes for these standard units where you can have self-paced learning for that. Due to Corona, it's a trend to have virtual classrooms, and this will be prevailing for the future also. You will have more and more trainings going in a virtual classroom. We have this virtual event right now. It's working out quite well. So also virtual classrooms is something where the trainings will happen. Yeah, web-based training is something that especially the younger generation is absolutely used to. You find the training contents online and you will conduct your trainings via web-based training. And even if you have some time waiting for the bus, you will use your mobile device and do training. And these are the trends where a training service provider needs to go, and they will be they will have more impact in the future with this trend that the big utilities will go away and that you will have smaller, more standardized utilities with more standardized assets they are operating. And that is, to me, the point where training service provider needs to go in the future in order to be existent in the future. Of course, there's another topic that we need to talk about, and that is also practical training. There will still be people operating plants and assets, need to maintain them, need to operate them with just the training tools that I demonstrated before. This is more for theoretical training, but also practical training needs to be done. And to me, although this practical training in the future will be conducted remotely with all the technologies that you all know, virtual reality tools will be used to do practical training for people maintaining assets. This is a trend that is unstoppable and will soon and will be the standard in the industry very, very, very soon. That's also why we are starting to incorporate that into our trainings and into our simulators that we are providing. From the general overview of where this energy system is going, and that there is a driver for having more remote training. I hope this was a bit clear in the presentation that I just had. I wanted to show the perspectives that we are currently doing here at the Simulator Center and what we already did achieve for these remote trainings. One first example is a Corona example that came up last year, where travels were restricted and operators couldn't come to do the trainings in our control rooms here anymore. So we came up with a, I would say, innovative way of conducting the trainings, because most of your simulators, if you have full scope simulators, are equipped with audio video systems. And the audio video systems that we operate here are so good with the resolutions and also with the sound that it was no problem for us to put the signals of the audio video system to our customers sitting remotely. Our instructor was allowed to be at the simulator. He was doing the exercises. Another instructor could operate the audio video system and show what was happening on the panels. And with this trick of using the assets that we had here, we could continue doing training even through the period where we had travel restrictions. And for trainings that are not really necessary to be at site, I could foresee that this could be done more often in the future. So it would be a very good possibility to reuse your asset again for remote trainings. When you don't have those hard panel simulators or those assets with the hard panels, where the industry is going more to screen-based simulators, and that's of course rather easy to provide remote training with these screen-based simulators. What we did for our last project was to host the simulator in our data center, because we are also operating our own data center here in Essen at the simulator center. And our customers were just logging in remotely to that simulators. We could share the screens between them. Our instructor was there and had them to do the testing. They were also using the simulators by themselves without any instructor there to just do the testing and training that they needed. And that was technology-wise a rather easy way to conduct remote training with screen-based simulators, because everything you need is just some equipment there, some screens, mouse, keyboard, and then you can log into the simulators. And to me, this is definitely something that is trending and will happen more in the future, because with all these standard small assets that are there, nobody is gonna buy a simulator anymore. They just want to have access to some remote training simulators. And we at the simulator have the technology in place to do that and to use that. So if you have some need for that, don't hesitate to contact me. And the last example that we did is a virtual classroom example. We did set up our own studio here at the Simulator Center, where our trainers can use the screens there and conduct the training in a virtual classroom environment. This was set up for some basic training or initial training for some Swiss operators. Some of you recognize the content that was taught here. The important thing here was that the trainees need to see the instructor, and the instructor needs to have the interference with its trainees. Therefore, we decided to come up with this setup where the instructor would stand in front of that screen there and can conduct its training. And that has proven to work out very well. Nevertheless, for classroom training, the instructors always mentioned that it would be good for them to have direct contact with the trainees. But again, also here, to me, the tendency will be that you will use setups like that, like virtual classroom setups, more and more in the future. And we already did that. We are using that. It's working out rather fine. So if you want to have more information about that, yeah, please contact me. So if I look at the clock, I almost used all of my time, and therefore I want to just summarize my views of this new energy system and the training needs that arise from that. Mentioned it before. It will be different. There will be lots of small utilities. Your customer base will change, especially if you're a training service provider like we are. You need to make sure that you be able to conduct training on a remote basis for many, many more customers than we did before. And for us, we are set up to do that. And I'm looking forward to this new energy system of the future, and we will see how it goes. Just at the end, one more slide for our product portfolio. I think it came a bit clear already. Of course, our main purpose is simulator training and simulator maintenance services that we're doing. But we're also doing simulator projects, be it online simulators, training simulators, full scope simulators. That is also something where you can contact us. I mentioned it briefly. We are operating a data center that we can use to host our simulators, or that can also be used for any other IT service needed. Combined with that is our IT security consulting. If you have any IT security issues with your assets, be it the real assets that you're operating or simulators like that, we can also assist you in reaching the IT security limits that you need to do. And you saw our glass model previously. So when travel restrictions are gone, I invite everybody to take a class here and have a look at the glass model. Then I want to finish in, if I had it right, the last minute of my presentation, to give you an outview. We are currently doing a rebranding of our simulator portfolio. If you're looking for the simulator center in the future, you might not find it. You might find EcoSim, which is our new brand for the simulator engineering, because we think that dynamic planning and control schemes, they work best with digital twin. And this is the look and feel of our new brand EcoSim. And yeah, probably at the next Global Energy Simulation eSummit, I will be presenting as a member of EcoSim and not the Simulator Center anymore. So I'll let you all know when the brand comes into the market, and then you can also follow that one. So that was my presentation for the new needs for training from a new energy system. I hope you enjoyed it, you learned something. I know it was a bit biased on the German energy system, but the tendency of all the other countries are the same. So thanks for your time. And if there are any questions, don't hesitate to ask me.
Hello, everyone. I am Evangelia Papadopoulos, Engineering Manager of Power Simulation at L3 Maps. You've heard already from Bernard and Hal, two of my colleagues, some of the great technology we're developing at L3 Harris. Now, I'd like to present to you how we have dealt with keeping our projects on track during the pandemic. So just to put everything in context, like every company, we've had to face different challenges in the last year. The current pandemic situation has forced us to do things much differently than ever before. Just to give you a bit of background on the situation that has been ongoing here in Montreal, Quebec, Canada. Quebec is the province that we're located in and has been the hardest hit province in Canada so far. Many strict measures have been put in place from the beginning. The government has been using a 4-color alert system throughout the province, with different regions having a different color alert based on their incidences. In the Montreal and surrounding areas in which we're located in, the region has been identified as red, which is the maximum alert. But what does this mean? It's essentially a lockdown of various degrees, in which restrictions are updated every few weeks based on the number of new cases and hospitalizations. At the beginning of the pandemic, in March of 2020, everything was shut down, schools and non-essential businesses. Although much more relaxed since then, many restrictions are still in place. For example, restaurants and bars have been closed and indoor gatherings are prohibited. At the L3 Harris level, from the beginning, L3 Harris was deemed an essential service, so we were able to remain functional, although with some restrictions for sure implemented, such as remote working, which was enforced where possible. There were travel restrictions imposed both from the government and the company, so all non-essential business travel was halted. For remote working, most of our employees have been working from home ever since. This was only possible due to the outstanding support we received from our IT department. They were able to make remote working possible almost overnight. Although some employees are still required to go to the office, it is really on an essential basis only. From the beginning, the company has done an excellent job in keeping everyone informed and uploading information on dedicated websites regularly. Our internal teams were, and they still are, having regular virtual meetings. Our executive team holds virtual all-hands meetings every few weeks. In some respects, our communication is even better than before. We even held our first ever virtual owner circle conference. I'd like to talk to you about that a bit more in the coming slides. For now, we're all still working from home, as you can see. Unbelievably, it has already been 1 year. Despite all of this, the business is operating well. Our projects are progressing, even though we've had to adapt to this new normal and conduct our business in a way we never thought possible before. So I'd like to give you a few examples of some of our projects and how we have adapted. The first project that I would like to talk to you about is the Wolsong 3 Full Scope Simulator project in South Korea. This is a project in which we were installing and preparing for our site acceptance testing when the pandemic began. In fact, back in February, we had resources on site in South Korea. At that time, when the pandemic hit, the project was put on hold and we repatriated our staff back to Canada. With all of the uncertainties of this situation, it wasn't clear when we'd be able to reconvene and complete our project. Many solutions were being evaluated, whether we can use local subcontractors in South Korea, whether we can simply conduct our acceptance testing remotely, or if we can eventually even send our staff back to the site. Around early summer, which is the time when travel bans were being lifted, we worked on more firm plans for completion of the project with our customer. Then we reconvened in the fall when we sent our staff and the subcontractor back to South Korea. This is when the panel installation was completed and site acceptance resumed. The travelers had to quarantine in a government-decreed hotel in South Korea for 14 days and had to quarantine for another 14 days on the way back home. This increased their travel time significantly. The project was successfully completed in November of 2020. The next case study that I would like to present is the Chernavoda Simulator Modernization Project. This project consists of two phases. One phase, which consists of a platform replacement and a partial model upgrade, and the second phase, which is an I/O system and power distribution replacement. We were in the early phases of the project when the pandemic began. For phase one, the modeling design review meeting had to be conducted remotely. We used Skype as our communication platform, and everyone participated from their remote locations. The model development and integration phases of the project were done with our employees all working remotely from home. The bigger challenge presented itself during the acceptance testing phases. Typically, our acceptance phases are completed with the collaboration of our team, but of course, with our customers. Given the travel restrictions and quarantine requirements in Canada, our customer wasn't able to attend at our location. Instead, we conducted these tests through remote support. In fact, we conducted our pre-factory acceptance and factory acceptance testing using two independent sites, in which the customer was able to test on their own at their simulator site, and we were able to test on our own as well on our platform. In order to make this possible, we had shipped a portion of the computer equipment to the customer location in advance. In addition, the secure remote access had been established, which would allow our staff to connect to the customer site and help debug with any problems. Of course, this was complemented by frequent communication with the customer through Skype. The pre-factory acceptance and factory acceptance test phases were completed remotely successfully. The remainder of the computer equipment was shipped just earlier this year, and installation is currently ongoing, with site acceptance testing commencing shortly. Following this site acceptance testing, we have an extensive remote training planned. Given the time difference, this training will be conducted in 4-hour sessions. For the phase 2 portion of the project, the design review meeting was also completed remotely. In order to accurately establish the design for the replacement of the I/O and the power distribution cabinets, we typically need to conduct a site survey. Our specialist would evaluate the current equipment and design. Again, given the travel restrictions, this was impossible. So yet again, there was another opportunity for work to be done remotely. In this case, the customer provided significant support. Once the design was established, the cabinets and the I/O system were developed in Montreal. FAT was recently completed, and SAT will occur this summer. Another case study I'd like to present is the work for Nextera, first for the St. Lucie Simulator Modernization Project. This project was also at the beginning stage when the pandemic hit. The design review meeting was held remotely with a customer, in which the design of every system that needed to be developed was reviewed. This review was completed through Skype with everyone's participation from their remote locations. All of the simulation models were developed and integrated together. All of that was done remotely with our staff all working from home. This was accomplished again with frequent communications with the internal team members and the customer. Our pre-FAT and FAT phases will also be conducted remotely. Once again, there are two independent sites set up here, one in Montreal and one in Florida. The customer will use their existing classroom or glass-top simulator for that purpose. We also conducted a training session with our customer at Turkey Point. In this case, we had two independent sites and databases set up, and we were exchanging schematics through transfer sets. Moving on to our UK projects. In both cases, for the Hinkley Point and Heysham simulators, we provided a computer system and platform replacement. Both of these projects were completed in the fall of 2020 and essentially followed the same deployment strategy. Skype was again used as a communication platform, for weekly communications with our customer, and FAT was completed using Skype screen sharing. In these cases, the testing was performed in one location, and the screen sharing was used for the other party's participation. SAT was then completed on-site with our on-site support. Luckily, we managed to have some exceptions to the quarantine requirements by having our staff take 2 COVID tests within a 48-hour period prior to entering the facilities. In China, we implemented the Siemens turbine control system update on the Lingao simulator. This was done with special coordination between the 3 different parties in the 3 different locations. It was one of the first projects where we completed acceptance testing remotely. The BOMGAR secure remote connection was used to connect to the simulator in China in order to provide the required support. For another customer in China, we conducted some training sessions, again, due to the time difference, in only 2 or 3 hour blocks. Our staff and the customer had to be flexible in their schedules since there is a 12 to 13 hour time difference. In order to provide this remote training, we had specific laptops set up which could connect remotely to the customer site and in which we can use customer approved AV communication platform. These laptops were completely independent from the L3 Harris network. One of the last projects I would like to talk about is a 3D visualization and immersion project from an undisclosed customer. You already heard Hal speak about this in his presentation. For this project, we are providing the customer a 3D replica of the plant, linked to the simulator, allowing for whole plant interaction for training and other purposes. Given the nature of this project, there were regular project review meetings planned to be held face-to-face as progress on this really had to be seen. For example, face-to-face meetings would include demonstrations that had been completed in that of what had been completed in that reporting period. We had to turn to virtual PRMs. To facilitate this, the detailed presentations were being prepared. They were coupled with extensive video packages showcasing the progress. Ongoing communications with the customer were held with Microsoft Teams. We set up a secure remote connection to our partner site, and all of our installations, domestic and foreign, follow strict security protocols. The factory acceptance testing phase had to be reevaluated as there would be a combination of remote and customer site testing required. Given the travel restrictions, the FAT testing was split into 4 distinct phases, where the customer site portion was minimized to only what was absolutely necessary. One of the add-on project deliverables is the ORCID 3D immersion environment, which you can see here in the top figure. This product was added to the project to enable whole plant training at the utilities headquarters, which is located just a few hours away from the plant. This enables the customer to extend the training to a larger employee population. We still have some more challenges coming up. The SAT phase includes a lot of parts which are still moving, and given the situation, travel and quarantine requirements which may be imposed, planning is paramount. Every year, we host in-person user meetings, which we refer to as owner circle conferences. We host these conferences at different geographic locations. In October of 2020, we hosted our first ever virtual owner circle conference. It was a very successful event, mostly because we were able to host our customers from all over the world, many of which would normally not even be able to participate. While we were initially apprehensive about the OCC being virtual, it actually turned out to be a great event. We had a vast range of presentations, both from our customers and from our staff, and we fully utilized features of the video platform like chat and polling for maximum engagement. We have also had our own internal celebrations. Besides all of the Zoom get-togethers right before the holidays, we also had a Zoom gathering to wish one of our own well as she went on maternity leave. It's not quite the same as getting together at the office, but I feel that it's still very important that we continue to stay connected with each other. This was one way to do it. So, and with that, I'd like to wrap this up. The pandemic has forced us to do things differently than we were doing before, differently than we may have ever even imagined. In our business, there's not a one-size-fits-all solution. We have had to adapt and provide solutions which are mutually agreed upon with our customers. We tapped into many available and acceptable communication platforms and secure remote connection solutions. Our IT department has been outstanding in supporting us and making all this possible. But most importantly, it's the cooperation and flexibility of our customers that is key. Otherwise, none of this would have been possible. For now, I believe we have all gotten used to less traveling, remote working, video communications, even though face-to-face collaboration is irreplaceable. Moving forward, even when all of this is said and done, we expect a blend of remote and in-person collaboration. I hope that you've gained some value from the information I've shared with you here today. I look forward to seeing you in person next time. Thank you.
Are your new hires disengaged and having a hard time grasping basic plant concepts? Are your experienced operators bored of PowerPoints? Let Simtronics help get your team ahead of the learning curve. We provide the right solution for your trainees at every level of learning, from basic fundamentals through advanced troubleshooting. Our training products will give you the tools you need to train console operators together with field operators, effectively teach skills for normal operation, startups, shutdowns, troubleshooting, and emergency response, and ensure operator competency through objective performance testing. Simtronics offers a structured training path for your operators to follow, from new hire to experienced operator. New hires start off simple with equipment tutorials and SPM e-learning. These tools help them rapidly learn all major components of the process prior to using the simulator by interacting with a library of movies, 3D visualizations, P&IDs, and DCS screens, all at their own pace. Once trainees comprehend the basic concepts, they move on to training workbooks, where they will learn to put the concepts together. These workbooks use a blended learning approach, providing a comprehensive curriculum for both basic operators and field operators, saving the instructor time and effort. Trainees can then move on to the simulator and virtual field operator for hands-on training. Here they can apply the knowledge they've gained and practice operation skills before moving into the plant. The highly sophisticated yet easy-to-use GES21 delivers a wide array of benefits to console operator trainees and instructors. A realistic training environment, comprehensive training, demonstrations of skills, improved troubleshooting skills, flexible training exercises, better knowledge transfer and retention, adherence to standard operating procedures, and measurable performance. With the GES100 simulator, trainees develop skills in a realistic plant environment, viewing graphics in either gray or black, whichever way works best for them. Data provided through the DCS helps trainees determine the root cause of various failures. Instructors can design unlimited training exercises using any number of equipment or instrument failures. Embedded tutorials and aids enhance blended learning. A robust performance scoring tool calculates an objective score based on multiple parameters. Running alongside the simulator, the virtual field operator is an interactive 3D training environment that enables trainees to learn about field operator responsibilities. The VFO allows trainees to trace flows and verify instrumentation back to the console for realistic troubleshooting. For higher-level trainees, the SimTech Library of Training Exercises focuses on advanced troubleshooting and abnormal situation management. No matter what level your trainees are at, Simtronics has the tools, software, and experience to keep them ahead of the learning curve.
Sicherlich kennen auch Sie die Situation.
You certainly know this situation. Once your plant is being operated, new data is permanently generated and existing data is modified. To be more precise, your entire plant as well as equipment is documented in the form of data. Everything you have to know about your plant, everything that really matters, is spread all over numerous software applications, databases, and paper-based files. This means this data and information can neither be accessed easily or quickly, nor does it have any useful correlation. We call this data dark data. Let's be frank. Can you actually rely on this data? What really matters is how the data can be managed efficiently across different disciplines and along the entire life cycle in order to provide relevant information for substantial decision-making processes.
Und hier kommt Planzeit ins Spiel. Planzeit wurde speziell für die Prozesse.
Here, PlantSight comes in. PlantSight has been developed in particular for the process industry and consolidates all information and data, be it static or dynamic. You can consolidate, contextualize, validate, and even visualize your data and information with PlantSight. The raw data is then transferred to a complete digital twin.
Ein lebendiges Abbild Ihrer Anlage.
It is a genuine copy of your plant, which is being updated on a regular basis and grants valuable insights. Suddenly, you realize new correlations and understand how everything is interconnected with each other, where to go further, and how you can actually work with the data right now. It doesn't matter whether you are an operations manager, site manager, engineer, or operator. PlantSight helps you reveal yet hidden data, make decisions faster, and thus increase the profitability of your plant immediately as well as on a long-term basis. All this is possible with only one simple web portal, which can be easily accessed. A completely new portal allowing for realizing and enhancing the added value of the digital twin along the entire asset lifecycle in process industries. Anytime, anywhere.
Jederzeit und von überall.
Siemens. Ingenuity for life.
Hi. Do you know simulation? I am the simulation. Do you know who I am? I am smart, but together we are smarter. I am digital. I am hardware. I am visible, and I'm not visible. I can be one, and I can be many. I can be the task or the solution. I can fly, drive, swim, and dive. I have a great network. I am virtual, constructive, live, or a process. Together we can learn the basics and try out your tactics. We can achieve a goal together and start over again. Together we see the future, live the present, and analyze the past. I can be any person you want me to be, but I am always your partner. I am flexible. I am mobile. I can assist your coach or be your guide. I can be your team player or your opponent. I can work for you or we work in groups, but you find me wherever you are. I am the simulation. I am a part of Rheinmetall.
Hi, my name is Janis Busch. I help customers in the digitalization of their business by building their real digital twin. Skilling and reskilling your employees is a challenging task. Technology is accelerating faster than we as humans can adapt. We have to cope with an environment that is volatile, uncertain, always complex, and often ambiguous. The only road to recovery is learning faster how to make smart decisions and we are the technology platform provider for this digital journey. I am going to show you how Rheinmetall digital operation support and digital learning can transform your business and boost your operations. We want to be your partner to take you to the level where you want to be. In the next couple of minutes, I will take you from some facts about our company to why we are the right partner for you. Rheinmetall is a company with more than 130 years of history and roughly 26,000 employees. Rheinmetall entered into the energy simulation market in 1986 and has since then made over 100 successful projects for the power generation and oil and gas industry. From our experience, we can tell that the use of simulation in a project can reduce the cost and testing time by up to 40%. Rheinmetall is a big technology company, which some might know from another context. Coming from a defense background, we have taken simulation to the next level. We simulate to win. We simulate to win because we cover all dimensions, ranging from flight, naval, live, transportation and land simulation to energy simulation. We are part of a big house of simulation, which enables us to provide you with a solution your business needs. My department, Energy Simulation, is a highly skilled and competent part of the Rheinmetall Simulation and Training Group. With over 35 years of experience in simulation for nuclear power plants, coal and gas-fired power plants, and since 2015 for the oil and gas industry. This timeline shows some selected projects from the past and present, and we are happy to share with you more detail about them if you send us a request. Let's talk about simulation in the energy market and what I can offer you using our experience. Industry faces many challenges today. Our workforce changes and new personnel must be reskilled continuously. New processes must be implemented into the existing ones. Health, safety and environment regulations must be taken into account. Unplanned downtime due to operator error can disrupt business continuity. Digital twins help us facing these challenges by providing insight to stay ahead of the curve and achieving business continuity, aligning technical and commercial interests across your domain value chain. Having mentioned the challenges, let me explain you the scope of our offer from digital learning to digital operation support. Based on our experience doing training centers, we were able to create our own digital learning concept, which is based on 4 pillars, which complement one another. Each pillar is fully customized to our clients' needs and processes. We have a strong competency-based e-learning platform, which is used for reinforcement of basic concepts and first principles. High-fidelity simulator systems based on our own simulation methods allow us to operate a virtual plant or a partial plant process under normal or abnormal conditions in order to strengthen our process understanding. These simulators are our bread and butter business since 1986. To give continuity, all our systems are powered by our advanced simulation platform, INVIDIS, which is a result of over 30 years of high-fidelity simulation. High-quality, made-in-Germany scale models complement our concept and give you the touch and feel of the real process. Transparent materials allow you to see what happens inside critical process components. All together is a solid base for a real digital twin. In the next slide, I will talk more in depth about digital twins and how they can be used in digital operation support. Our digital twin approach is a full replica of all of your plant systems independent of their initial technology provider. We combine this with a 3D VR model of your asset, which is connected with the simulation and can be operated by the avatars of the field operators. This full digital representation of your asset is a real digital twin with the potential of being the anchor point for the digitalization of your business processes. Our digital twin can be used in many aspects of operation optimization, covering the whole life cycle of your asset, beginning even before its actual construction. It allows multidisciplinary teams to interact in a realistic way with the objective of an efficient operation of your asset, managing risk, optimizing cost, and thereby increasing overall productivity. It can support operation and maintenance by pre-testing plant changes, assuring business continuity. One of the topics we are currently working on is operation and maintenance prediction algorithms, which will help to reduce unplanned downtimes in the future. I'm showing you an example of an oil and gas project we did recently, giving you some impression of how our digital twin looks like. Due to Corona, the project has not yet been launched. This is why I cannot yet give you the exact name of the reference oil field. But here are some facts about its coverage. Our digital twin covers an oil field consisting of a production platform with pipeline-connected satellite platforms and the power generation platform. This digital oil field is producing about 200,000 barrels per day of crude oil. The simulated scope of this simulator covers the main oil and gas separation and transport process, the power generation and electrical grid process with its producers, consumers, and backup devices. All platform safety systems, from emergency push buttons to fire extinguishing systems, are simulated. The complete set of turbo machinery installed on the platform is modeled in depth, including the auxiliary systems, from combustion gas conditioning until the actual combustion process. The satellite platforms and their processes are modeled completely, starting from the well until they reach the pipeline to the production platform. We also modeled auxiliary systems like instrument air for pneumatic control or the flare systems. All these simulated systems are interconnected and affect each other as they would in the real world. It is also worth mentioning that we made full replicas of all installed digital control systems independent of their original supplier. This gives you the true plant behavior in all of its aspects and makes our digital twin a real digital twin. So why do we think we could create your reality? Our biggest asset is our team and the experience we have. This, combined with our solid, unique and proven platform, allows us to cover from power plants to oil and gas, from nuclear to fossil, from upstream to downstream. As mentioned before, we are a vendor-neutral simulator provider and happy to implement whatever system you use. Rheinmetall brings a very strong and healthy financial background, which allows us to realize big training center projects. I also mentioned Rheinmetall's training centers before, which can be found all across the world in different industries and cultures. We are not only experienced engineers and managers, but also experts in working in cross-culture environments with teams spread all over the planet. Our most recent training center project in the energy market is CAP Mexico, a turnkey training center for the upstream oil and gas industry, where more than 200 people can be skilled at the same time using the latest Rheinmetall technologies based on our 4-pillar digital training concept. In this training center, we have available for each student 21 e-learning courses, each one available for 3 different skill levels. Also 12 complex process simulators, also available to each student at each time. And 1 digital twin with 3D VR replicating one of the biggest oil fields of Mexico for interdisciplinary team exercises. Additionally, we have 6 fully functional scale model trainers. CAP is an on-premise training center. Nevertheless, the technology we use for screen-based learning and simulation is cloud-ready and could easily be hosted on another infrastructure. So who is Rheinmetall? We are the leading company in defense and automotive and a strong global brand. Coming back to where we started, I would like to put energy simulation into context in the Rheinmetall Group. Rheinmetall Defense is structured in 3 main divisions, which are weapon and ammunition, vehicle systems, and electronic solutions. The energy simulation of Rheinmetall is part of the business unit Integrated Electronic Systems. What we all, as Rheinmetall, with our different products have in common is our passion for technology. This pandemic has transformed our relationship with technology, and I'm looking forward to being your technology partner in these tech acceleration times. My name is Janus Busch. Thank you for watching. It was a pleasure to virtually meet you, and I'm looking forward to chatting with you online.
Security. It's the feeling of being reliably protected, the basis for economic growth and prosperity. Mobility. The dynamic that powers our lives, a fundamental prerequisite for freedom and cross-border ties. Security and mobility, 2 forces shaping the future of markets and mankind, and Rheinmetall's raison d'être. With over 20,000 employees at some 80 locations worldwide, we produce high-tech solutions that deliver optimum security and environmentally sustainable mobility. Security requires well-equipped armed forces. And before an army can take on new international responsibilities, it needs the right tools for the job. German soldiers and their colleagues from other like-minded nations serve as guarantors of security and freedom, putting their lives on the line to protect us. Technological superiority is the ultimate insurance policy for soldiers deployed in harm's way. Rheinmetall systems are synonymous with protection and security, whether on land, at sea, or in the air. We're pointing the way with passive armor technology, smoke obscurance systems, and unique active protection systems. But force protection is only half the battle. We are equally at home in the domain of air defense or high mobility vehicle systems, because survivability often depends on maximum mobility. Information superiority in every phase of an operation is more important than ever before. Achieving this requires a sophisticated nexus of state-of-the-art sensors and reconnaissance systems, keeping our soldiers one step ahead of their adversaries. This is the challenge we've set ourselves. This guiding principle forms the basis of Rheinmetall's wide array of cutting-edge simulation and training systems. From desktop simulators to complete combat training centers, our technology ensures that troops receive the best possible preparation before they deploy. The driving force behind all these products, Rheinmetall's total commitment to force protection. Always has been, always will be. Making mobility as sustainable and environmentally friendly as possible. This is the formula for success of Rheinmetall's automotive units. Today, we're already working on the engine of tomorrow, which will be smaller and lighter, yet more powerful than current engines. Achieving this requires superbly engineered components. Engine blocks, pistons, and plain bearings have to be as light as possible, smooth running, but still capable of withstanding extreme stress, because less weight and lower friction mean greater fuel efficiency. We're leading the way with innovative systems for exhaust gas recirculation. Today, our intelligent, high-performance water, oil, and vacuum pumps set the standard worldwide. Secondary air systems for uncompromising, fuel-efficient engine design significantly reduce harmful exhaust emissions. And we're well equipped with technologies for tomorrow too. Take our innovative range extender, a world first, which is already helping to make electrically powered engines a practical proposition. Rheinmetall Automotive, going the extra mile to make future mobility sustainable. Innovative, robust, and present worldwide, Rheinmetall serves the international automotive industry and the armed forces of nations around the globe. Building on over 100 years' experience, we're proud to play an active role in shaping the future of two of mankind's most basic needs: security and mobility. Rheinmetall's twofold mission.
With more than 20 years' experience of research and development within eye tracking, we know that the eye holds many answers. We track, measure, and analyze human eye movements, turning sights into data and data into insights, creating a deeper understanding of human behavior, intentions, and interactions all over the world. We develop the world's most advanced eye tracking systems.
name is Ilya Simonov. I'm head of Krok Immersive Technologies. We are IT company. We produce virtual reality trainings for industrial enterprises. And today I'm gonna meet you and show you example of successful implementation virtual reality training to the business processes of chemical company Uralchem. So, and before I start, I wanted to meet you and introduce myself more personally, and to start from my own story and to move forward to the content for about training solution. So this nice picture that you can see now, I could see every day when I was young, because I was born in a small town close to Moscow region, and we had one of the largest enterprise chemical company, chemical plant in our town. And from this time, I experienced I experienced industrial industrial experience. I had industrial experience, and first time I experienced safety training of evacuation from like area which close to this plant. And from this time I understood how industrial trainings, safety trainings are important for the people who work on these facilities, because if something happened dangerous, so it will affect not only on the process of the company and plant, it can affect for all area which close to this plant. So let's go to real life, and I will start from the hero of this story. This company called Uralchem. Actually, it's chemical company. They produce mineral fertilizers for all countries, Russia and other countries. So they have 4 branches, and these 4 branches are operated by 10,000 employees. So this production is quite specific, because they produce their products all the time that cannot stop. All of these plants, they have continuous production, and if something stops, so they will lose money, they will lose their products, and so on and so on. So many problems can be faced when something stops and when something works wrong. And this is quite huge problem, and this is problem for administration of this company and engineers who operating these plants. So this unplanned downtimes can be the reasons of these unplanned downtimes can be different. Actually, we can analyze 4 reasons why this plant can stop. So first of all, of course, it's dynamic equipment which works every day, 24 hours, and so we need to repair this equipment, dynamic equipment. We need to stop, we need to maintain, we need to repair. So second is, of course, materials, technology processes. So it can be poor quality of materials, and third and fourth reasons. So these reasons which we are focused on when we creating virtual reality trainings. Third reason is electricity. So if electricity will disconnect the production line, so it can stop all the production. And fourth is human factor. So this is not absolutely automatically operated plants. So people are involved to this process of operation. And so, of course, the education of engineers, workers who operate the plants is really highlighted problem, and they have many challenges how to do it faster, how to do it efficiently, and so on and so on. But the idea is we need to teach all these 10,000 people, but who we need to focus on and to prepare them more in efficient way. So it can be a lot of trainings to be done for these plants, but we focused on the main one. Main one is electricians who operate power substations, who operate power substations, and this is the most risky work in this plant, I would say. So let's go to the challenges we faced when we started to work with Oralchem, and we were trying to solve their problems. First one is when we want to prepare people to work in real life, we need to do it on existing equipment, and the equipment is working 24 hours, 7 days a week. So it's almost impossible to prepare people to react on some emergency situations, to prepare them how to operate real equipment without stopping this equipment. So, and some trainings are impossible to provide while this equipment working. So the second problem is long adoption time, long onboarding. To become independent electrician, it takes almost 5 years of internship, of education, and so on and so on. 5 years to become independent electrician who can do like independent work. And third one is for management. It's almost impossible to control the level of skills. For example, we have 20 workers who can be managed, who can be administrated. And these workers we can divide on like high experienced, high qualified workers who work more than 5 years, almost 10 years. And we have part of them who just came to the facility, to the plant. And we need to prepare them for independent work and to decrease number of errors, number of some problems then which they can face. So of course the solution is to teach people on real equipment, to simulate something, some training solution where we have real equipment, but to recreate this physical process is quite costly, and it's almost impossible to recreate a whole technology process. We can create some training solution for only one equipment, or I don't know, 2 or 3, but it's almost impossible to simulate all the process of working of engineers. So about scope of work we've done, we focused on only electrical power substations and on 20 electricians who operate the substations and 6 substations. So as I already said, to become independent worker, it takes almost 5 years of internship and like preparation for independent work. And they have only once a year planned downtime for 1 or 2 weeks where they need to repair, to maintain the equipment. But only this period of time, this slot, they can train people to work by hands, to do something that they cannot do during all the year. So this is the big problem for management, for people, because they feel fear of working with real equipment. When they see electrical schemes, instructions, and so on and so on, it's quite okay. But when they go to a real facility, so they feel quite dangerous. So let me explain you what is virtual reality training and how it works, what it contains. So first of all, we needed to create digital copy of the real equipment and real processes. This is how it looks like in real life, and this is how it looks like in 3D and virtual environment. So this is absolutely the same copy of the equipment that Oralchem has in their substations. So Actually, this is not only like a 3D environment. This is training solution which contains equipment, virtual reality equipment, and powerful PCs, software which contains 3D copy of the facility, and scenarios where we can start, for example, shutting down of the old bus station and to repair it, and then we can launch it again to the operation. So this solution contains all these parts. This is how it looks like when electrician works in these scenarios. Here, from the first view, what he sees when he puts on a helmet, and he can do all the operation that he can do in real life. So it's absolutely immersive, and this is not only like clicking what to do next, what to do previous. So electrician, he must do it by his hands. So he do all the processes from the beginning to the end. So this is how it looks like from the graphic side, because the main point is to not to recreate the equipment how it is in real life. You can see all the details that we needed to digitalize using photogrammetry, using laser scanning. So it's almost the same copy of the equipment that they have in real life. The problem is that for new plants, for new refineries, they have already like new equipment. We can find a lot of drawings, a lot of, I don't know, even 3D models of this equipment. But this case we worked, it was equipment, I don't know, 40 years old. So it's almost impossible to find some documents for recreating this data. So that's why we used real equipment, and we did many photos, laser scanning, and now you can see the picture in the VR training as it is. So this training, when electrician goes through this training, his work every time is recorded, and after he's done, management can see what he did during this training. So, for example, he made some mistakes during this training, and it's really essential part to go back to see what he did, how he did, and what can be, what they need to work together, what problems can be faced there. So now I'm going to show you video how it works, and the most important is what the feedback from the users and from the management. So before we implement this solution to real life, I thought that VR, virtual reality technology, is quite complex to understand how it works, to start working with it, because virtual reality is close to gaming solutions, but people who work in dangerous facilities, they don't play games. So they operating real equipment and they have dangerous work. So, and now you can see what the feedback from these people and how they apply these simulations. So let's see.
Interview with the Eurocam representative, Ilya Alexandrovich. Hello. Let's talk about the project background and try to understand the reasons behind simulator implementation decision. We faced the need for components and high-quality training for our employees. Unfortunately, our plant does not allow for employee training on the existing equipment during the year, since it is always energized because of a continuous production process. Such training is only possible when the plant is stopped for scheduled repairs, which is very rare, once a year or once every 2 years. Since employees cannot be trained on the running equipment, gaining hands-on skills may take years. The use of VR simulator will help us dramatically accelerate the process. Please describe current personnel training process. Now, before an employee is permitted to make important critical switching, he must work as an electrician for 2-3 years and take an internship under the guidance of an experienced mentor. Only then he will be permitted to perform some actions independently. Hands-on skills can only be practiced once a year or once every 2 years, which is hardly acceptable since true mastering requires a long internship, continuous training, and repeated performance of the same sequence of activities. Let's talk about the use of the virtual simulator. Routine switching program has 2 basic scenarios: shutdown of the RP15 bus first section for repair and bringing it into operation. How many employees will be trained on the virtual simulator and how frequently? We plan to train 15 to 20 people on the VR simulator every year. These are mainly those who must know and maintain substantial equipment. The simulator helps employee get ready for the profession of a shift electrician without visiting a substation. A picture is good and helps to master skills. When operating a running system, an employee will know what to do and will no longer be so scared. The simulator can record training and testing sessions, generate reports, and export training statistics. What are the key features you will consider when determining whether a specialist is ready for the safe work performance? I would like to see that an employee not only performs certain operations with high quality and competence, but also his development progress, such as error rate and error severity reduction, so that there are no critical errors or faults. What main business benefits do you expect to get from the virtual simulator following the pilot operation? First of all, we want to reduce switching operation error rate and enhance reliability of the power supply of the entire enterprise. You're just starting to use the simulator, and the business effect is not yet known. However, you have already tried the solution during the acceptance test and obtained a result. Does it meet your expectations? Yes, it does. We have done a lot of work to create the simulator, and we hope it will help us a lot in personnel training. Numerous factors should be considered to create a true simulator rather than just a nice VR picture. What your industry peers who are new to VR should note to avoid mistakes and get a high-quality training solution. VR simulator developer should have expertise in Russian energy domain and understand what we want and how to achieve this. I would highly recommend you to pay attention to the personnel's feedback. Your expectations should be in accordance with their opinion, as evidently they are the vital resource that's going to bring your project to life. That is, how effective and how useful it will be for the employee who makes switching operations and will rely upon the knowledge gained from this program.
As you could see on the video, if you go to the link, you can see how it works and what the feedback. So in the end, solution work like this. So there is virtual reality equipment and software part. Virtual reality equipment quite simple. It's head-mounted display with plus joysticks and powerful PC that can run this virtual reality simulation. So it packs to the box and it looks like this. So it's it's almost plug-and-play solution where we can bring it to training center. We can bring it to, I don't know, a room close to operational room where electricians can do this training during their like daily routine operation. And so I would love to go back to the challenges again and to explain how it works now and how it affects on business processes. So training is impossible on existing equipment. Now training is possible without touching real equipment. So, of course, this is not only one solution that can educate our people, electricians to work, but this is a way how they can train their skills, how they can prepare during all the year, not to wait for one plant downtime a year. So long adoption time. This solution is provided to the plant, but it also can be used in universities, in training centers who prepare people to the plant, to work on the plant. So they can start training before they go to the plant, when they educating and when they studying at university. So, and impossible to control levels of skills. Management, head of this bus station, power station, he get every time he get notification when engineer has done the training, and also he has video of how this training was done. He can see it if there is some highlighted points, for example, some errors that electricians faced. So he can go back and to see this video and to make some decisions. And comparing to physical training solution to VR training solution, it absolutely different from the budget perspective. Now, for example, we need to scale this project to the another power substations. We need to change software. We don't need to change equipment. We need to change software. And now it's quite easy comparing to create again physical equipment for this equipment which quite old. So from the budget perspective, it's quite great. But our idea is not to provide only like PEC as a solution, or our idea is to solve the issues and solve these challenges. And how we do it now. After we provide the solution, now every time, every half a year, we measure the results and feedback from the final users. So how they work, is it comfortable or not? So how many mistakes they do, and what are the mistakes? So we analyze the feedback from the final user, and so we measure all these metrics, and after that we can say efficient this solution or not. So this is what we are working on after we implement the solution. So this is it about this success story. You can find my contacts here. Thank you for your attention. And in the end, I would love to invite you to our booth. We have where you can find many videos, many presentations, and also I will be there with my colleagues. We can discuss everything if you are interested in implementation this kind of solution to your processes. So thank you very much. It was nice to share my knowledge. See you on our booth. Thank you.
Hi everyone, my name is Sarah Grace Mitchell and I'm the sales manager with Chorus. I'm excited to speak to you today about dynamic simulation, its use in the energy and chemicals industries, and talk about the qualities that make a good simulator. Following my brief presentation, you're going to hear from one of our engineers, Mr. Suhas Kulkarni, who will give you an in-depth demo of one of our models. At Chorus, we offer a wide range of solutions based on simulation. Our primary offering is high-fidelity custom models of your facility, which act as a digital twin and can be used for troubleshooting and procedure validation. We are DCS independent, and our software is compatible with all major DCS systems. In addition to custom models, we also provide lower capital cost standard models, which are available in the cloud with multiple different HMIs. These are great for training and operator fundamentals. Alongside our models, we offer custom training solutions, such as our companion training manual, as well as train the trainer services. Additionally, our engineers can provide their knowledge via consulting through dynamic engineering studies and what-if analysis. Now that we've briefly covered Chorus's offering, I'd like to make sure that we're all on the same page about what an operator training simulator is. So if you compare it to a plant has process units like an FCC or a distillation unit. There are field operators who are in the field opening and closing valves, starting and stopping pumps and more. And you have a DCS control system, and you have an SIS or ESD control system, and you have your DCS operator stations inside your control room. Now, if you look in the operator training simulator world, the process units are modeled in Chorus's Indus Plus dynamic simulation platform, which runs on a Windows desktop PC or a Windows server. We offer an optional field operator station where a field operator trainee can perform those field functions. This can also be incorporated into the instructor station. The DCS would be simulated by a DCS simulator, and the SIS is simulated by an SIS simulator. Then you would have your DCS operator trainee stations. The component that doesn't have an equivalent in the plant is the instructor station. And this is where the instructor will run the simulation, introduce malfunctions, activate training scenarios, and more, which we are going to see in just a minute in the demo. Though it's commonly associated with trainers and operators, the OTS can actually be used by everyone within your organization. Engineers can use custom models to streamline your process and test new control schemes. And operators, both new and experienced, use it to train on everyday procedures and more uncommon emergency conditions. Managers can utilize it to lower operating expenses, and HR enjoys its easy integration with your LMS and capture of best practices and knowledge transfer. Chorus owns a proprietary simulation platform called Indus Plus. It's high fidelity and extremely accurate in matching the actual plant performance. It can be used for DCS link or emulation. It also easily allows for linking to third-party software via the CAPE Open Interface standard, which allows for plug-and-play interoperability with third-party process modeling components such as compressor or reactor models. It also includes a trending and data historian, and it allows for using DCS graphics on the instructor station and field operator station HMIs. It also has some advanced functionality, which we're going to get into more in the demo. These are all of our standard models that we can provide. These are our standard refinery models that we can provide. We provide both component or small system models, as well as models of entire refinery units. These models are available in the cloud on a subscription basis with no software license fees. And please contact me if you'd like more information about these. With the subscription, we include setting up the selected models in the cloud and providing login credentials to the instructors and trainees. And we provide training sessions for the users and the instructors with additional support as needed. In terms of training materials, the models come with a user manual, which gets granular in the descriptions of the process unit and control scheme, as well as the simulator functions and startup procedures. Then we also provide a customized companion training manual, which is a classroom curriculum and description of the custom simulator training scenarios developed in coordination with your site's SMEs. Finally, as an option, we can consult on your overall training program and develop a training master plan to incorporate multiple simulation models into the curriculum, which is especially useful for the models that will be used for multiple sites. Now I'm going to turn this over to my colleague, Suhas Kulkarni, who is going to give you a demonstration of our simulator capabilities.
Hello everybody, I'm Suhas Kulkarni. I'm a lead engineer at Chorus. Today I'll be demonstrating the Indus Plus operator training simulator software. I'll be showing you the instructor station and the emulated DCS operator station. So I'll be going between the two views. So one screen will be the instructor station and the other one will be emulated DCS operator station. So let's get started. I'm going to first start the instructor station view. So there will be an icon like this on the instructor station in the OTS. So I double click on it. So the instructor station is where the trainer or the instructor sits and basically controls the training session. He runs the simulation, he can freeze the simulation, he can introduce malfunctions, scenarios, change battery limit pressures, temperatures. So you get a splash screen. So I'll click on the title. So this demo is for a single distillation column. It's a debutanizer application. So it's a column with all its peripherals. You have a water-cooled condenser, a reflux drum, reflux pumps with one running and one spare. You have a steam heated reboiler. You have a water-cooled bottoms cooler. You have a pressure controller on the reflux drum, so it's a vapor product here. You have the feed system with the feed control valve. So if you look at the top here, this is an instructor toolbar here. This is where he can do a lot of instructor functions. So let's start with the starting point for the simulation. So if I'll click on this drop-down menu, I see a lot of these initial conditions. So initial condition is a starting point for the simulation. So I can start with normal operation, which is basically where the plant runs most of the time producing the product at capacity. Or you can start at a cold start initial condition. And this is basically all the equipment is shut down, pumps are stopped, valves are closed, all the equipment is de-inventory, depressurized and at ambient temperature. So this would be the starting point for a startup training exercise for the trainee operator. But normally we provide about 2 to 3 initial conditions with the simulator, a normal operation, a cold start, and maybe a hot or a warm start. But the instructor can create many initial conditions during his training session. So it's very easy to save an initial condition. So let me load my normal operation initial condition. To save an initial condition, you just go to this and type the name of the initial condition you want to save and click on save. And now it will be available in the drop-down menu of the initial conditions. So it's saved on the hard disk of this computer. To run the simulation, you would click on the run button here. So you can see that the simulation time is increasing. So that means the simulation is running. So the simulation is built to run in real time. That means any process changes that would take about an hour or so in the plant would take the same time in the simulator. So if there was a feed upset and it takes about an hour for the plant to stabilize, then it would just take the same time in the simulator. You do have a speed up function, so you can speed up the simulation. So I go to fast mode and now I run it. So now I'm running 10 times faster. This is normally used during startup, so like pressurizing and inventorying the process. That's when this speed up function is used. Otherwise, during normal training, you would run at normal speed. So the other functions that are available to the instructor are the field view. So there's an FOD button here. When he clicks on the FOD button, he can see all the field functions available to him. So you can see the cooling water valve appears. It's a manual valve in the field, which is not shown on the DCS graphic. So when he clicks on it, it appears, plus all the, if you click on a control valve, he can now operate the upstream and downstream block valves. You can operate the bypass valve. You can fully open it. So this can be used, for example, for control valve failure kind of exercise. He can stop the pump from the field. So let me go back to my normal operation here, run it. So the other feature available for the instructor is malfunctions. So I'll click on my malfunction button here, and now I can see these Thunderbolt signs on all the equipment where there's a malfunction available. So for example, on a control valve, the instructor can fail open it, fail close it, stick it, put leakage or plugging. So if you fail close the valve, then I have to click apply to ensure. So the valve fails close and the flow goes to 0. So this is the situation where they can operate the bypass valve to operate the process. So basically isolate the control valve and then use the bypass valve to operate the process as close as possible to normal operation. Other failures are pumps, like all motor driven equipment, like a pump can be fail stopped. Also instruments have malfunctions, so any transmitter, flow transmitter, temperature transmitter can be fail low, fail high. So fail at its low range, high range, you can freeze it, bias it, add noise, drift. So I can fail this transmitter low, that means the flow is going to go to 0. You also have standard malfunctions for heat exchangers, so you can foul the heat exchangers. So let's go back to, I'm going to load the normal operation. The other function available to the instructor is what we call instructor variables, which allows him to change feed conditions. So you can change the feed temperature, feed pressure. So wherever you see this hand with a pen, there's an instructor variable available. So this one allows the instructor to change the feed pressure, temperature, the feed composition. He can also change the cooling water supply, pressure or temperature to simulate like cooling water failure, complete loss of cooling water or partial loss of cooling water, or the cooling water temperature going up or down. So these can be used to simulate different scenarios, different kinds of upset that might happen in the plant. You can mimic those in the simulator utilizing these malfunctions and instructor variables. In addition to this, you also have what we call as custom malfunctions, which allows you to basically introduce process-specific malfunctions like tower flooding or foaming or hydrates formation. So these are programmed in the simulator based on the customer input, and they are customized for every process. So I'm going to now switch to the DCS operator view, the emulated DCS operator. This is where the trainee operator sits and performs his function. So I'm going to start the emulated DCS operator station. So you will see that the graphic is basically the same as what we've been seeing on the instructor station. So again, you get the splash screen. However, there is no top toolbar, so he cannot run the simulation or pause it. That's an instructor function. So he basically operates from this screen as if he were in the control room and operating the real plant. So I'll go to the instructor, make sure that I'm running the simulation, and now the operator basically can open the like a PID faceplate for this flow controller, change the set point, maybe decrease the flow to 35,000. So you can see the valve is closing. You can monitor it on the trend. You can put the controller in manual and reduce the valve output to say 45%. So you can see green is the controller output, red is the set point, and blue is the PV. So it went down. You can put it back in auto and give the normal set point of 35,000 and let the controller take the process back. You can monitor the process. He has a trend overview, so there'll be a trend available just like a DCS. So this is what we call a generic DCS that kind of Chorus has developed for its generic kind of simulators. But when we emulate a specific DCS like Delta V or Centum VP or Honeywell Experion, then all these faceplates and the graphics will look like those DCS graphics. So we would make these graphics look like your plant graphics. But for this demo purposes, we are using what we call a generic DCS look. So let's do a simple exercise where the instructor introduces a malfunction. So he's going to trip a pump, this running reflux pump. So he's going to turn on his malfunction view and basically fail the running pump. So as soon as he does that, we'll switch to the operator view. The operator will see that the flow, reflux flow went to 0. He sees that the pump has stopped. He can go and see the alarms. So the alarm, the low flow alarm is active, so you can acknowledge the alarm. Navigate back to the process graphic. So then he needs to diagnose the problem. So in this particular case, you can see that the pump has stopped, the running pump, and he has to start the standby pump. So this, since this is a field operator pump, he has to tell the field operator, in this case the instructor, to start the pump. So I'm going to switch back to my instructor view, and on the instructor I'm going to go to my field view and start the pump. If you had a separate field operator station, then it would be this function of starting the pump would be done on the field operator station. So now the pump is started. So I'm switching back to the DCS operator view, and he sees that the pump started, the flows are coming back. So you can see the PID controller is trying to take it back to its set point. So then he can monitor the process and ensure that everything is going back to normal. He can take whatever corrective action he can on his DCS screen. So now the instructor decides that, okay, this was a good exercise. Let's go back to the normal operation and run the simulation. So this time we're going to do the same malfunction, but we're going to use what a feature that is called training exercises. So let's look at, so you can develop these training exercises which are basically malfunctions or actions that can be programmed and then can be run as an exercise. They can be run by the instructor or by the trainee, and they would not know what's programmed in that exercise. So let's look at this exercise one that was prepared for this demo. I'm going to edit it. So these exercises are developed like a flow chart. They can be either programmed by like dragging and dropping these different functions on here, or you can also record them. So if I'll walk you through this particular one. So the first step in this exercise is to load a normal operation initial condition. You can change that. You'll have the same drop down menu. So you start with the normal operation initial condition, then you start the simulation, you run it for 10 seconds, and you can change that if you want. Then you introduce a pump failure, the same pump that we failed manually before, the running reflux pump. Then you start a program called TPM, an Indus Plus program. It's trainee performance monitoring. Basically, this allows the program to monitor certain variables, and those variables are programmed by the instructor or by us for the customer. And then it monitors those variables for 5 minutes here, and that's basically the time you're going to give the operator to recover from this upset of the pump failing. and then the TPM program will stop, and then the simulation will stop. So whenever this exercise is run, it's going to run for basically 5 minutes and 10 seconds for everybody. Anybody who runs this exercise, you can see it's 5 minutes, 10 seconds before the malfunction, and then 5 minutes after that. So if you want to look at what's in the TPM, I'm going to go to the TPM tab here. I'm monitoring the reflux flow, and I'm giving it a limit of 33,000 to 37,000. So the normal process value is about 35,000. So I'm saying that the reflux flow should be between 33,000 and 37,000 at all times. The level that I'm also monitoring the reflux drum level, and it's at 50% normally, and I'm saying that it should be between 48 and 52 at all times. I'm also giving a weight, so whenever these variables are outside their limit, what's the weight, what's the penalty, how heavily should the operator be penalized. So for example, reflux flow is more important, so it carries a weight of 2. The level not so much, so it has a weight of 1. But you can basically have a weight of anywhere between 1 to 10. 10 being the highest penalty and 1 being the lowest. So you can program as many variables as you want for any exercise. So now I'm going to run this exercise. So I just click on run. So it's going to ask what is the instructor name for this, who's the instructor for this exercise, who's the trainee. So say it's going to be John, and do you want to compute the evaluation score. So you can either check it or uncheck it. So if you check it, then it's going to give you a score, and you'll see it in the end when it dumps a report of the exercise. So I'm going to start the exercise. So now the system loads the initial condition normal operation, then it will run for 10 seconds. So let's look at this time, 10 seconds. And then it will activate the malfunction for this pump. So the pump failed stop. Again, the flow is going to go to 0. And so now on the DCA screen, the operator is going to notice that the pump has stopped, the flow has gone to 0. So he has to basically start the standby pump. So he's going to tell the instructor to start the standby pump. So on the instructor station, I'm going to go to my FOD view and start the pump. So now you can see that the pump has started and the flow should be starting to come back. So now I'm going to go back to my instructor view. It's a 5-minute exercise, so I'm going to speed up to get to the 5 minutes because there's nothing more to do in terms of corrective action. So you'll see that at the end of 5 minutes, the system will create a report of the exercise and also give a score for the operator performance on this exercise. So we are getting close. So then the system report generates a report. You can see that. So it's the AT, the exercise is exercise 1. That's the name of the exercise. Instructor is myself, trainee is John. Duration was 5 minutes and the score was 86%. So that's pretty good. So it gives you a statistical analysis of all the variables that were being monitored by the TPM. So for example, the reflux flow crossed the low limit alarm once, which is expected because the pump stopped, and it crossed the high limit because the flow controller, the reflux flow controller wound up to 100%, and so you had a spike. How long was the excursion below the low alarm? How long was the excursion above the high alarm? How many low, and what was the total excursion time if you had multiple excursions, and the score for that particular performance of that particular variable. So similarly, it gives the same statistical analysis for the level. It also gives you a trend, and the trend you can zoom in or zoom out. You can also see the values. So this is a PDF file, but you can go and scroll and look at the values. How high was the peak? You can see the peak on the reflux was about 43,000. Similarly, you get the trend for the level. So goes up to 70% and then it's coming back down. So you have all the data that you need. It also gives you how the score has been calculated, the formula being used. So this can basically be dumped to your LMS system, your learning management system, or saved in a folder, or we can print it and save it in a binder. But it becomes basically part of the trainees training program. So now I'll briefly show you the actual engine that basically runs this thing. So this is the Indus Plus model. This is the engine that runs under the hood. So this is the model that's running in the background. So this is how we build the model. So if you look at this, there's an overview sheet, and then we create sheets for every PNID. And if I go to the process, I can navigate here to the column. So this is what the column looks like in the model builder. So here's the feed system. So here's the feed battery limit with the pressure, temperature, and the composition. So you can see got some butane, hexene, hexane. This is the flow control valve. So the valve, you have to provide the valve CV, the nominal CV at 100%, and the characteristics. So it can be a linear valve or equal percentage valve. So for the column, you have to, it's a tray by tray simulation. So this particular column has 22 trays plus the bottom drum. They are all sieve trays. We provide all the dimensions for the trays. The heat exchanger, the reboiler, it's a shell and tube, so you have to provide the heat transfer area and the heat transfer coefficients. For pumps, we have to provide the pump curve. So we have a library of all these unit operations. So if you go to the library, you can drag and drop. So if I want to create a pump, I will basically create a pump, drag and drop it, and provide the pump curve. So I can provide the pump curve. Similarly, if there was a compressor, I would provide the compressor curve. If I have a valve, I can drag and drop the valve, provide the CV and the characteristics. So this is how the model gets built for the process. So this concludes the demo of Indus Plus. If you have any questions, let us know. Thank you.
Thank you, Suhas. If you have any questions, please do not hesitate to contact me. We're happy to provide virtual lunch and learn presentations to your organization, which include a demo of our software. We will also be putting on a series of webinars this year addressing simulation needs, best practices, and case studies. So please contact me for more information if you would like to be a part of those webinars. I appreciate your time very much and enjoy the conference.
With more than 20 years' experience of research and development within eye tracking, we know that the eye holds many answers. We track, measure, and analyze human eye movements, turning sights into data and data into insights, creating a deeper understanding of human behavior, intentions, and interactions all over the world. We develop the world's most advanced eye tracking systems.
Welcome to this presentation on how head and eye tracking can provide additional clarity in research and HMI activities for energy control rooms and simulators. My name is Ulf Laffberg and I'm the sales director for Smart Eye in Sweden. I will be joined by our systems engineer Emil Rolander, who's going to perform a system demonstration after my slideshow. Emil will show you how our solution is helpful when it comes to HMI design, operator training and operator monitoring. But first, I'd like you to follow me into the world of eye tracking as we experience it here at Smart Eye. My agenda touches three main topics. I'll speak to you for about 15 minutes, during which I'll explain what an eye tracker consists of and what it produces. And I will show you a few use cases in which our systems have been deployed with our customers. And finally, I'll explain in more detail why head and eye tracking is relevant for the energy sector. After that, Emil will take over. Also for about 15 minutes, he will perform the system demonstration. So what is head and eye tracking? Our head and eye tracker measures certain biometric features in 3D. These are the head position, head orientation, eye position, gaze direction, gaze intersection with predefined areas of interest, eyelid opening, blinks, and pupil dilation. By studying eye, face, and head movements, the technology can produce data from which you can draw conclusions about alertness, attention, and focus, and thus gain insights into a person's awareness and mental state. Infrared light is used to create a reflection in the eye's cornea that can be captured on camera. Algorithms then identify the iris and pupil of each eye and weigh the two monocular feeds into a consensus gaze. The software also detects, tracks, and interprets the person's facial features and head movements. Over time, the system gets to know the face of each subject, learning more about each person while building a more detailed profile. This means that only a few features need to be visible in order to accurately determine head pose, even if the face is partially obscured. A multi-camera system also lets the software triangulate the position and orientation of the head with greater accuracy, regardless of real-world conditions. So what parts does the system consist of? In essence, the hardware is made up of IR flashes, video cameras, and a processing unit, a PC. The job of the hardware is to present video images to software algorithms. The flash and camera hardware come in different packages. Each is suitable for different situations and different environments. The most common hardware is a so-called bar tracker. It's a fixed configuration with flashes and one or two cameras. These can be used for screen-based eye tracking. Usually the tracking works on one camera only. The field of view is limited, as well as the distance between the bar and the subject and operator. Another type of eye tracker is one where the flashes and cameras are mounted on a frame that you wear head-mounted, glasses. These solutions provide an unlimited field of view, but they're not comfortable to wear over a long time, and they do not offer real-time data. The third type of hardware is single-unit flashes and single-unit cameras. Working with single units allows for flexible configuration and positioning. By placing multiple cameras, up to 8 typically, remotely around the subject, caters for a large field of view both horizontally and vertically. That means that even if the head is turned to the side or up-down like helicopter pilots or operators in a control room, the head and eyes will still be seen by cameras and the biometric data can still be captured. In addition, since remote solutions sees the whole head and face, other features like Face ID, Operator ID can be concluded and reported. The multi-camera approach is the hardware that is most suitable for control room, since it offers sufficient field of view, and the hardware is placed remotely and therefore unobtrusive to the operator. This slide is indicating a situation commonly seen in control rooms. Several screens on a desk in front of the operator, and a big screen or projection on a wall further away. One single head and eye tracking system is able to track the gaze behavior on multiple screens at different distances and different angles or heights. To Today, off the shelf, the head and eye tracker needed for research, development and design in the energy control room and simulator case is already available. It is the SmartEye Pro DX solution by SmartEye. The core of the solution is the tracking software running on a PC delivered with the system. Through image analysis, the algorithms produce raw 3D biometric data, as per the list mentioned earlier. The data is accessible in real time and it is time-stamped for synchronization purposes. This data can be used for two categories of investigation: gaze data analysis and biometric analysis. Gaze data is used for analysis of gaze fixation and answers the questions: what is the operator currently looking at? This in turn can be used to enhance operator training and HMI design processes. Biometric data is used for safety analysis like operator monitoring and answers questions like: is there an operator in the seat? Who is in the seat? Is the operator sleeping? Or how drowsy is the operator? Is the operator paying attention? And what is the current stress level of the operator? These analysis applications are not available off the shelf. They're typically developed within the research projects. I'd like to highlight that the SmartEye Pro system has been in use for more than 20 years. It is deployed in several different industries for both research and live production applications. Here are a few examples of industries where SmartEye Pro is deployed. Aerospace. NASA has eye trackers installed in the flight deck simulators as well as their research flight deck, where they're used to monitor pilot state and gaze behavior. Aviation. Eye trackers are used to enhance training and education of pilots in simulators. In just a few years, the aviation industry is expected to start single pilot operation and hence follow the automotive industry and install eye tracking devices in cockpits in order to track pilots' attention and drowsiness levels. This is while flying, so not in the simulator. Automotive. In the development of autonomous cars, eye tracking is a central part of making this new technology as secure as possible. Other areas where SmartEye Pro is used is clinical research, communication, medicine, neuroscience, and psychology. The following few slides show use cases from our customer base. Here an example from the University of Linköping in Sweden. The multi-camera remote eye tracker SmartEye Pro is used to analyze workload in a remote tower scenario as well as in a ship bridge scenario. We have a number of customers using our tool for research in the transportation field. Here cameras are placed in the cockpit of cars, aircrafts and respective simulators to gain further understanding of pilot and driver behavior. Also HMI design processes commonly benefit from head and eye trackers in this field. And as mentioned, research around driver attention and drowsiness is often based on these tools. A very specific application is already being deployed as we speak. It's not research, but a ready feature in standard production cars. So head and eye tracking as a consumer product. In the automotive world, it is called driver monitoring system. The technology is available to you and me now on the street. BMW is one of the OEMs offering so-called DMS as part of a safety feature package. Eye tracking cameras are installed behind the cluster or behind the speedometer and enables the car to warn the driver when drowsiness or inattention occurs. The DMS also reports on the driver ID. The ID can then be used to alter preferences based on who is driving. For example, seat and mirror positions, radio channels, HMI themes or layouts, comfort settings, etc. In aviation, several projects already aim at introducing eye tracking as a standard part of the pilot training. These systems are currently in R&D and proof of concept process or stage, but will very likely soon be deployed in pilot training facilities across the world. Head and eye trackers help the flight instructor, to determine and evaluate pilot gaze behavior in specific flight maneuvers and during problem solving and crisis management. Further down the line, we will most likely see pilot monitoring solutions built into flying aircrafts, much like what we see materialized in the automotive industry today already. Here, examples of camera positioning in the cockpit. To the left, an aircraft cockpit, and to the right, a helicopter cockpit. So now on to my last topic for the slideshow. We see several scenarios now already in use in other industries that are relevant to the energy control room scenario. The three main topics being HMI design, operator training, and operator monitoring. The physical build-up of a control room is different to what you see in a car, aircraft, or small workstation scenario. That makes the energy control room unique. The control room has more screens, larger screens, several screens at different height and distances. The operator in a control room may have to move around more compared to a pilot or driver sitting in a fixed seat. All this is a challenge for normal eye tracking solutions, but not for Smart Eye Pro DX multi-camera solution. As you will see soon, with one multi-camera head and eye tracking system running just one algorithm, you can track the gaze behavior and biometric features of an operator. The robustness and flexible configuration of the Smart Eye Pro DX solution allows for deployment in most control room workstations. The Smart Eye Pro system delivers raw 3D data in real time. However, specific applications should be added to achieve complete systems that perform all needed analysis steps, visualizations, and report creations needed for research projects and potential production systems in the world of energy control rooms. Third-party analysis and reporting tools are available today. The iMotion software is one example, which we will show you briefly later. It is, however, reasonable to assume that new applications shall be designed and tailored for the energy sector. These could include the following features or functions. We mentioned them already. I'll just dig a little bit deeper this time. So, operator training. Gaze behavior analysis and comparisons based on pre-existing templates. Different templates for different scenarios. A scenario could be standard information collection during system monitoring. Another could be troubleshooting, or the third scenario could be crisis management. Since the analysis is based on factual behavior, the system would fall under the term evidence-based training and execute automatic rating of an operator with the purpose to improve training efficiency. This should be considered very valuable both to instructors and trainees alike. A second feature or function could be HMI design. This is similar to operator training. Also here, operator performance is analyzed. The difference is that it is not the operator that is evaluated, but the HMI system itself. By measuring how well the operator performs the design, the designer of the HMI is able to customize the setup of the complete workstation. Location of screens, what information goes onto what screen, and with what theme or size, what flow and sequence of information is best used to make it as easy as possible for the operator to perform the duties. These are some of the questions that would be answered. The eye tracker, together with adequate application, can be a very helpful tool for the designer. It's likely that the above two applications, or the above two features and functions, operator training and HMI design, would be deployed in simulators. The last example of useful applications for the energy control room is, however, intended for daily use in the live operation centers. We're talking about operator monitoring. The purpose of this application is to help understand when the operator is in a non-optimal mental state. By using head, eyelid, and pupil data, and applying drowsiness, workload, and Face ID algorithms, it's possible to create warning systems within the control room. As always, there are certainly other ideas pointing at other features and functions where eye tracking can be useful in the energy space. We're open to discuss any further topic you might have on this. I assume this is a lot of new information to some or many of you. I would therefore like to summarize the most important points again. The basic technology is here and proven in other industries. By that I mean that the most complex part technically here something that has taken us 20 years to develop. The eye tracking sensor itself, the Smart Eye Pro solution, is already available. It's here, and you can start using it immediately. We definitely think that the use of eye trackers is possible in the energy sector and also wanted in the energy sector. And last, if you use eye tracking in a control room, you do need a broad field of view, and you need something which is not disturbing the operator or interfering with your study. That's why we recommend our multi-camera unobtrusive head and eye tracker. So that summarizes my theoretical introduction. We're now moving over to the demonstration, so I'll hand it over to Emil. Thank you very much.
Hello, my name is Emil Rolander and I work as a Smart Eye engineer here at Smart Eye. I will today demonstrate a 3-camera system in this highly improvised control room, and I will focus on mainly 3 areas. One of them is HMI design, the other one is operating monitoring systems, and the third one is Smart Eye in the sense that we can use it in a training purpose. When it comes to HMI design, it's quite common to have 3 main goals of the system to be able to operate fully. Is that usually you need a wide field of view to be able to see all of these screens that we want to show. You want high accuracy to really pinpoint where am I looking on these screens, and to have the system to be non-intrusive, so blend in the environment. So a researcher might be interested in looking at gaze behavior and gaze patterns of these different screens. And depending on the information you get, you know, if you're looking on one specific instrument, a warning lamp, or maybe different gauges in the environment. And while the output data gives you, you're able to suggest improvements to the system, or just to know that the HMI works because the highlighted effect of this gauge might be visible to you. As we can see in my environment here, I have a bunch of monitors, both high and low, and I even have one wall mounted behind the normal array of monitors. So this is a quite complex setup. And to be able to capture this fully, I have deployed a 3-camera Smart Eye Pro system, and I can manually mount individual cameras behind or below the monitors to capture the gaze of me as a participant. Even going above these screens to capture that one is still possible for all cameras to see me and not lose any of the data that I'm interested in. Due to the small form factor of our cameras, it's really easy for us to integrate them into any environment and to make them be, as we call, non-intrusive and adapt to any situation. For example, we have a wide array of monitors here, but if they were stacked vertically, we would adapt to that situation and instead position the camera slightly differently to blend into that situation. You could, of course, also adapt the system to any other environment, and in that sense we can increase and scale the systems to have even more cameras. We can go up to 8 cameras to adapt to almost any complex and advanced situation. In general, I would suggest that a system designed to do the HMI design studies could also just as easily be used to create something for training purposes, since they both share these common demands for high accuracy, wide field of view, and to really be able to tell where this operator is looking. And if, of course, then apply it to be able to optimize and improve exactly in what stage of a training you might to spend some extra time, and to maybe not have the time invested in spending a lot of time in expensive simulators or different environments. So just to optimize what you can do with the training system where you spend time. I want to show you how this could look inside our graphical user interface in Smart Eye Pro, to show you kind of like what we can see, and you can easily understand what the benefits of an eye tracking system in these instances could perform for you. This is the 3D world model view, And this is a simplified representation of the real world, built by two-dimensional objects like screens and planes. We can populate it with as many objects as we want to and just place them freely in space wherever we like. As you can see, some of them tilt and some are a little bit more like straightforward. And of course that we designed by building this thing. You can even see the top screen here being quite much behind the other screens. And by rotating it, you can clearly see my head, which is the green ball, moving, and the red gaze vector that intersects with the different objects here. So it's a quite intuitive way of seeing my head moving, my gaze moving, with all the other objects. And this is the image view. This is of course where the real magic is happening, since this is the screen where you actually see your face and the eyes and the parts that we want to track. And I really want to show you how robust this is, so I can actually try to provoke it some now by covering one of the cameras and really how quick the refinder is. So even if I lose tracking here really by looking at a completely other direction, you can see it's really just snaps on within like less of a second. We sometimes talk about the head box, and that's just another way of us describing how much we can move side to side and back and forth within the environment. And I mean, with higher resolution cameras, we can achieve an even bigger head box as we have here. And if the system isn't perfectly static, or you as an operator move a lot of times, you have the opportunity to move within this head box. So it creates some freedom of movement, and that's great as well. And if we need to improve this even further, we can always add more cameras to go well beyond what you see here. And as I said before, we can scale it up to even 8 cameras, and that could be a full table full of equipment, and we can freely move within that space. When it comes to the aspect of the operator monitoring systems, it's usually more related to the human state of mind or the mood or mode that operator is in right now. And usually it's a lot about safety. Is the operator aware or alert to perform the task at hand? Can we at early stage detect the degradation of the alertness? Like head position or head rotation could, in combination with maybe eyelid opening or eyelid state, act as an indicator over different focus areas, but also show in which state the operator might be in. Is we are asleep or alert? And of course, like, is there even an operator behind the equipment? And the lack of an operator could maybe signal a state of something. So to be able to handle the sheer amount of data that is being collected from SmartEye Pro, it's usually a good practice to use some kind of analysis software. In this case, I've chosen iMotions because I really like how the visual representation looks and everything being collected and recorded. But it also have a lot of useful features, like aggregating different participants on top of each other for the same study, but also the fact that it's super easy to put together a specific analysis for a specific moment during that study, for example. You can see here up to the left that we have a scene camera recording everything that is happening. And as a layer on top of that recording, I can put my eye tracking data. So I, both in real time but also post-processing, can see what the operator, and I mean that's me in this case, are looking at. There is a fixation count within that view as well being shown, and along with that expanding circle, that's also showing how long my fixation actually lasts within that fixation. And of course the gaze trail, which shows you the movement of my gaze pattern. Down below you have some signals I've chosen. In my case here, I've chosen pupil diameter, the distance between my head and the tracking system, but also my position in the x-axis for this system. And at the bottom you can see my consensus eyelid opening. So it's essentially every time I blink, you can see that the number is falling down to 0, but also how open is my eyelid when I'm not blinking. At the top right you can see the world model again, almost as we saw it in SmartEye Pro, but here it's in iMotions. You can easily see the head movements and that the eye tracking remains really robust and precise. And I mean, that's why we don't lose any data, and we can clearly see my head moving from left to right and closer to the screens and back from the screens. And yeah, it's just an easy way of seeing how everything happening, even if me as an operator falls out of the view of the scene camera. When it all comes together, we can see that the interaction between human and machine becomes more and more intricate for every passing day. In developing products, environments, and machines that are made to operate by humans, it's crucial to understand these interactions from both technical and human perspective. And that concludes my demonstration of the SmartEye Pro system in this control room environment. I would like to take the opportunity to thank you and for you to pay attention for me and my colleague as we demonstrate and talk about our system. I really hope that we have inspired some new plans or thoughts and gave you some good ideas about the future. Please, if you have any questions or anything at all, just contact us. Go into our webpage online and click around.